Yeah, we are able to see it.
Okay. Okay. Good to know Uma, Mohammed, and Manoj. Let's start off with the Java and JE fast track training. As I said, it's going to be a 15 day training, approximately 3 to 4 hours every day. It should be covered between 50 to 60 hours, uh, based on, and periodically, that is every 4 to 5 days, we shall also have um, some interviews sessions, and I can give you tips on what kind of
Mm-hmm.
questions could be asked during the interviews. And if you are also planning to prepare for any certifications like any Java certification or something like that, I could give you some tips on that as well. Um,
Okay.
uh, then coming
So,
to,
by the way, what is your good name?
I am Pawan. I am Pawan.
Pawan. Okay.
Yeah.
Yeah. Okay.
And yeah.
So, Pawan, don't you? I mean, the thing is, there is no hurry.
Mm-hmm.
I mean, there is no time limit to complete in 15 days.
Mm-hmm.
Even it is like 20 or 25 days is fine.
Mm-hmm.
Uh, but don't skip any topics, and please, like make us code,
Mm-hmm.
make us
Yeah.
able to code.
Yes.
That's the only motive. That's what I need.
Mhm. Yeah, I
Yeah.
completely understand that. This is not, see, if we're not, if we are not meant to be coding here, then we will definitely not be sitting here. There are a lot of Java relevant videos out there on YouTube. You could just refer to them and then say that you have already prepared, but that's not the case, right? So here you will be getting one-on-one attention, and I'll be giving you exercises to actually code, to actually design your modules and then code them. So the focus is going to be on the the actual kind of work that you would be doing in the industry.
Yeah.
So looking
That's
at, so let's start off with a brief introduction to MindsMap. You already have applied through MindsMap for this training. So let me just go through briefly the different resources that you have on the MindsMapped site. If we start off with, the first one that you have over here is the details of the Java and J2EE training that we would be going through. So they're given about that, and they also we also said like what would I learn at the end of the course. So if something is not covered, you can always ping me, and you can tell that this thing is not covered or something. So you can have this as reference. There are a lot of things that we claim that we are covering over here, and there are a lot of this particular training is going to prepare you to work as a Java developer in any of the companies out there. So it's going to be a very practical, hands-on training. Apart from that, if you want to do any Java certification, you would also be able to do that. And it's about, you already know who is conducting the training for you. They also given you the Java J2E course curriculum, and frequently asked Java and J2E questions. These are, very high-level questions on why did you select Java, why do you want to go for Java, what is the future of Java technology, Hibernate, Spring, Struts, for people who really don't know what exactly those are about. So they're given very high-level overview of that. And then there is a second link, which is a link to the knowledge base. uh, when you get into the link to the knowledge base, you have different options, which you have to get into the Java J2E knowledge base. So you click on that, and it takes you to the Java and J2E knowledge base, where you will be able to see a lot of different questions around the Java and J2E being discussed. Okay, so this is, yeah, this is going to be a knowledge base. I'm going to share this PPT with you and also the links, so you'll be able to go through that. And apart from that, the third link that I'm sharing with you is to the knowledge assessment module. Now, this is a good thing to have, when we are actually going through the different lessons that we are conducting. You could go through different topics and say you pick up something like declaring variables in Java. You click on that and it throws to you different questions on, and which of these variable declarations will the variable remain uninitialized unless it is explicitly initialized. So these kind of questions, you should be able to answer these kind of questions after the training sessions are done. In case you are not able to, please let me know and then we can discuss any of these questions. This will help you in assessing how you are doing and how you are learning, how well you have learned the topics that have been covered in the course. I suggest you regularly visit these links. And there is one more link that we have, and that is on the resume preparation and mock interviews. If you look at the resume preparation mock interviews, it has a lot of resources on how you should be writing a minimum resume, how to attend a job interview, what are the things that you have to keep in mind when you attend a job interview and such. There is a lot of content over here. There are a lot of useful practical content based on there's so many consultants who have worked with us before this. So I will be sharing these links later. You may please go through these links um, and try to especially the knowledge base and the knowledge assessment module. There are a lot of questions that you would help you also in preparing for the interviews as well. Okay, and then
Okay.
yeah.
Pawan, I am getting some disturbance from, I don't know from whom, but I'm getting from noise.
Yes, I too can hear that. Now is it okay?
No,
I think I too am getting some disturbance from somewhere.
maybe like, is it some fan disturbance, I guess? I don't know.
I don't know, but could everyone else mute your speakers for a moment, your mics for a moment?
Yeah.
Is it fine now? It should be fine now because the disturbance is not there anymore for me. Manoj Mohammed, can anyone confirm if it was okay now?
Yes.
Okay, okay. Now, since I've already spoken to all the three of you, Manoj, Mohammed, and Uma, let me try to memorize the names. I'm not that good at remembering names, so please forgive me if I don't remember them. But since I know your background and know your expectation, in terms of expectations, do you have anything else apart from being very practical and want to be able to code using Java and using Spring and Hibernate and Struts and any other uh, framework that you would come across? So, is there any other expectation from your end?
Would we be also learning about web services?
About web services, yes, we would be learning. That would be an introduction to web services. Let me tell you, if you could, we could go through the Java JE training course content. Uh,
Yeah.
wanted- this would be something that's already shared with you. Um,
Yeah.
So if you look at this, the first few sessions that we have is on Java and object-oriented programming using Java, the different Java class library classes that we have in the libraries, and then we slowly start moving on to the connection to the database from Java and then serialization concepts. And starting session 13 is what is listed over here is the Java Enterprise Edition, so JEE, and Hibernate. And then we also cover struts and Spring. So let me tell you each of these topics over here: core Java, be it core Java or enterprise Java or Hibernate or structs or Spring, we would definitely be covering almost all the important points. But then it takes a lot of practice and experience to, come to a certain level where you are called an expert in that particular area. But what we can do is we go through each of those concepts, and for you to be able to apply those concepts, we'll give you certain exercises that you can work on. Once you start doing the coding, you'll start feeling, uh, better with those concepts. But then it would still take some practice, but you'll before you'll be able to call yourself a Java architect or an expert. But you will definitely be able to call yourself a Java developer. You will be able to, you'll be far, you would, after this, you wouldn't need another training before you actually work on Java. So you would actually just be able to refer to some material and then start directly coding on it. But Java is so vast, not everything can be covered. Spring in itself can take months to learn. But this will cover those basics of Spring and structs and Hibernate that will take you to a point from where you can take yourself forward. Is that fair enough?
Yeah,
Yes.
that's good.
Okay. And okay, so what we have here is Core Java, Enterprise Java, JSP Servlets, Struts, and Hibernate, and JMS. And this covers a lot. This covers a lot. So this covers almost all of what is required of or expected of a Java developer. So if you go for any interview, you'll definitely be able to clear if you say you know all this. There's nothing more that they expect.
Mhm.
Okay. So there's covering all this in 15 days. Let's move on. Um, let's
Like,
move at a
what
pace
has
that is comfortable for all. I'm not saying that does anybody have a requirement like it has to get over by January 17th or something? Well, we'll.
no? Yeah, I want to say the same as what Manoj said, that like we both are fine, like even if it extends more than the 15 days, but we want to get the concepts like, I mean, clear. So, and also apply everything practically. So that's the main motive of this training. So even if it extends beyond 15 days, it's perfectly fine with us. But we do not want to rush into these concepts and get it.
Yes. So we'll focus on the concepts. We'll cover every concept in detail because getting these concepts is very important. Looking into the API, getting the right API, and then working on it is actually not a big task. You can always refer to the API, get the right method, and apply it. But you will not be able to apply the right method unless you understand the concept. So the focus will be on concepts, but there will be an equal focus on actual hands-on doing some projects. So if you look at this syllabus that you have here, not only do you have mock-up interview sessions and sessions on resume preparation, um, you would also be doing some project work as well, which covers all these concepts. Okay, so okay, let's move on then. Let's keep it interactive. We'll not rush, but I have to make sure that you understand the concepts. So where you don't understand, do you know, do stop me and tell me that you not understand something, and then we can talk about it and then discuss and then get it clarified. Is that all right?
Yeah.
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 Okay, so this being the first class, I have just kept it to, introduction to Java. Why do we have this programming language in the first place? What is the history? And this history is from a programmer's perspective. It's not the history from, the kind of history that we have in social science. It's not on who did what. It's about why do we have this programming language in the first place and what are the salient features of Java. Then I'll show you how to set up your environment for Java development. And then we'll go through some object-oriented programming concepts. Is that okay?
Yeah. Cool.
All right. All right. So let's start off with an introduction to Java. Okay. Uh, so why? Tell me, why did you pick Java training in the first place? Why not? Why not some other language? We have a lot of other languages that people are working on. We have C, we have C++, we have so many JavaScript libraries, and we have whatnot. We have so many other software packages that we could learn. We could learn SAP. We could do so many other things. Why Java? I want to know from each one of you as to why you picked Java, maybe in a line or so.
The only thing is we have a lot of opportunities from Java,
Okay,
job opportunities from Java,
okay,
mm, and moreover, like it has good salary package too.
okay,
Mm, yeah, because if we go for me in my case, if we go for Java, we have so many people around to help us uh, ar- in the subject. Hello.
yeah,
But when compared with the other languages like Python, Ruby on Rails, like the job opportunities are also less, and the people who can going to support us, like all were going to be very less. So that's the only reason for picking me up Java.
okay, okay. All right. Anything else? I agree. I agree with all the points. Who was this? Was this Manoj?
Yeah, I am Manoj.
Yeah, Manoj. Yeah. Yeah. Anything else, Mohammed, Uma, as to why you picked Java?
It's kind of the same for me too. It's like an open source platform where it is widely used in many companies. And if you see, like, I mean, there are plenty of opportunities for like web applications, like Java web applications using all these three frameworks. So I thought it's the best to start my career with. So
Okay.
Same,
Okay.
same for me too.
All right. Okay. I agree. I agree with all the three of you. Yes, it's an open source. It's very easy to learn because everything is available for free. It's not something like, one of the SAP packages where you would have to actually buy the license before you start learning it. And and there are a lot of people to support it, and it's well developed, well thought of, and there are beautiful frameworks that would help you in doing your job. And there is good pay, and there are a lot of job opportunities. And when you come to server-side programming, this is leading. This is is leading. If you look at it, maybe 8 to 10 years back, there was the Java versus .NET thing going on. But now, if you see, Java has won the race kind of, and it's like Java is still the prominent language when it comes to server-side programming. You may have to equip yourself with a little bit of JavaScript, which I think I got it from my training coordinator, that someone was expecting me to cover Ajax as well. Is that true?
yeah, I asked for it because when we develop the web applications and if your page is JSP, then it is better to also know about the Ajax concepts, right? So,
Yes, I also agree with that. And keeping that in mind, it would be better if you would equip yourself with a little bit of JavaScript as well. Now, is JavaScript in any way relevant to Java? Does it,
no.
does anybody have any idea?
Can you come again? Why I would
Uh,
say this object
is,
oriented?
is there a relationship between Java and JavaScript?
Uh, Syntax wise.
Okay, let me tell you, Java and JavaScript are two different languages. They've got nothing to do. It's just a name that sounds like Java. JavaScript has the Java in the name, but it has got nothing to do with Java. JavaScript is a completely different language that was primarily focused on client-side programming. Java was focused on server-side programming. Okay? Java and JavaScript are completely different programming languages. Please remember that. There is no relation between Java and JavaScript. Okay. Um, Before we see, why do we start even looking at Java? Let's go a little bit into the history. So, and that's how I would like to introduce Java to you. But it is going to be a programmer's, a computer scientist perspective. All of you are computer science students, right? So let's start off with, the European agricultural revolution, which is around the 1700s. We had something called the agricultural revolution that happened in Europe. What happened during that time is that, they were able to multiply the yield of crops in the fields. So they were able to have more crops in the field. They were able to increase the produce in their farms, okay, by using certain techniques. And one of those techniques was by using this seed drill that we can see in the pic here. Now, this is something that was, a couple of horses were driving this kind of a seed drill. What is happening here is in the farm, as it is flowing, it is also dropping some seeds onto, the field, and it is actually planting those seeds. So it is sowing those seeds. And this kind of a machine was used to make the work faster. And this, as people had large pieces of land and they used this kind of machinery, the produce in those farms also increased. Now, if you look at, why Java, or you ask any technology question, it always has to come from something called a business intent. There has to be, and a business intent comes from a human necessity. There has to be some necessity because of which you come up with some kind of a technology. Now here the necessity was to grow, to have more grains or more produce in the farms, to have more crops in the farms. So if you look at our roti, kapda and makan, it's like that. It's like either you need more food or shelter or you need more clothing. So this has always driven, been the basic human necessities, and this has driven, people to invent new things. And this seed drill was invented around the 1700s, and later that agricultural revolution led to something called the industrial revolution. And in the industrial revolution we had something, uh, you know, do you remember James Watt's steam engine and all that? That actually, those kind of machinery that they invented and used in factories, that helped in increasing the produce in the farms, in increasing the clothing that they were manufacturing in the factories. So there was a boom in the textile industry as well. Okay, so these kind of basic necessities have always driven that. Now, when we had started having factories, say that were, manufacturing uh, clothes, say something like some, um, say cotton clothes. So if you have a factory that is manufacturing cotton clothes, and if there is some problem with the machinery, okay, and suddenly the clothes start getting defects, how would you know which machine has the problem, right? Did you understand my question? You can stop me if I'm going too slow or if I'm going fast, or if you're not understanding the question, please stop me. So if you have a garment manufacturing factory, and in that factory, what you have is you're seeing some kind of a defect in the clothing, and you don't know why there is a defect in the clothing. then you have to identify like which machine inside that factory has caused this issue. And how would you do that? You know, so they started coming up with more machinery that would give them some kind of a computation. Whether a particular machine is revolving or rotating in a particular speed, so there was some sensor that would measure the speed of that, and then it would give an output. But before it would give an output, say during those days of punch card systems and all, it used to be very slow. And before they would even be able to tell which machine was causing the problem, there would already be so much of defective cloth produced, and that would cause a lot of loss in the factories. Okay, but still there was a need for machinery that would compute. Now, does anybody recognize any of these devices that we see in the slide here?
No.
Okay. The one on the left-hand side that we see here, this this was used for calculating logarithms faster. So you would be able to do multiplication and division faster. Whereas all the four machinery that we have on the right-hand side are calculators. They're all calculators, and they used to, be based on mechanical systems. Um,
Oh,
if you
okay.
look at the one in the middle bottom that looks like a cylinder, what they would do is like they would adjust the digit or the number in the middle, and then they would be inputting the numbers here in the middle, and then they would have to take this handle at the top, and they would have to start rotating it a few times for it to be able to give you, say, the multiplication of two numbers. Say you input
Wow.
say you input 20 and then multiplied by say 30, and you rotate it a few times, you will get 20 by 30 is 600. Now, these were the initial calculators. The calculators that we see today, they're much faster and whatever, but these were the initial calculators. And these were based on mechanical systems, not electronic systems. So this makes us think, we already had mechanical engineering and we had computer engineering or computer science based on mechanical systems. What was the problem? You know, so that leads us to a question. What led to the evolution of electronic computation systems, right? So, so more specifically, what is the question? When we already had mechanical computing machines, so we already had calculators, right? So then why did we have to invent something called electronics and base our modern computing systems or computers on top of electronics? So by now I
For
think,
automation,
sorry,
for automating some of the stuff.
yes, okay. To a certain extent, they were able to still automate it. Any other guesses?
To make the work easy.
Okay,
Also do like more complex work.
okay,
Faster time.
Faster.
right. Faster, faster is one. Okay,
Effective utilization of time.
yeah. So if you are doing it faster, you'd also be effectively using time. So the answer to this is one is the switching speed, and the second is the wear and tear. Mechanical components are always exposed to wear and tear. They're always moving, brushing against to say gear teeth. So the one of the gear teeth could just come out or could break, and then there will be wear and tear. And the most important point is the switching speed, and that was to save time. Just imagine how many calculators of this kind would you need to compute a complex whatever that we do today, a complex computation that we would do today. If 20 by 30 doing 20 into 30 is equal to 600 would take 5 rotations. Just imagine you have big numbers and you would want to multiply them, just multiply them, would you keep rotating them, and how many times? So if you look at but this still had something called an arithmetic and logic unit. So this had an arithmetic unit inside it, and it had these components switching, but the switching was not fast enough. Say probably how many times could it switch? Maybe 100 times a sec, 100 times a minute, or maybe 1,000 times a minute if it rotates faster, but not faster than that. So that would limit. So this switching, the switching speed limits the computation speed. Because of which we invented something called diodes and transistors, and then we had electronics engineering, which was much faster, and today we know that we can do millions and billions and trillions of operations per second, because the speed of electronic switches are much faster, and it is just this that led to electronics. Okay, and now let's move on to the basic computer system. If you look at the building blocks of a basic modern computer system, it's based on the von Neumann architecture. And von Neumann, as we know, he was a Hungarian computer scientist. He is well known for this diagram that we have over here, where we have in the middle, we have the CPU and main memory, which form the basis of the main heart of the computer system. And on the left hand side, we have some things like the keyboard, mouse, and scanner, which are inputs to this computer system. And on the right hand side, we have the monitor and the printer, which are the output to the computer, output from the computer system. That is how you're taking the output. And then if you had to store some data for later use, you would store it in, say, the hard disk, or a CD or USB or whatever you use. So this is a basic building block of a computer system. I think all of you have gone through this, right?
Yeah.
Yeah. Yeah.
Okay. So if I had to ask a question, say, we have something called main memory here, which is nothing but, say, RAM. Okay, you're storing some of your information in the RAM. You're doing all the computation, and finally storing it in the hard disk. Now, if I had to ask you, why are we finally storing it in the hard disk? Why not in main memory itself?
Because let's say like we're using a software, the software might be like huge, like I mean, so the hard disk it hold it as a permanent,
Hmm.
and when you use the software, it load onto the memory.
Mhm.
Uh, Probably like also memory is like it's faster. Like a main memory is of only of small amounts of data.
Mhm.
It can only store like 1 GB or 2 GB.
Mhm.
Hard disk can store a lot.
Mhm.
So the main memory is only for like retrieving the data from the hard disk. It's just gets the data, fetches the data from hard disk and throws back to hard disk again.
Okay. Any other guesses?
It's an like an external device so that you can always use it on some other systems.
Mhm. Okay. Okay. Use it on some other system. All right. Okay, I heard two answers here. One, because the main memory or the RAM size is less. Say today, how much RAM do we have on a laptop? So say 4 GB, 8 GB. Say even if you have one 100 plus GB or whatever, maybe that is not sufficient, and we would have to store it in an external device. That is one answer that I heard. And the second answer that I heard is to share it with someone else. For the first answer, I would ask one more question as to, if we say that the RAM size is say less, I have only 4 GB RAM, but I have 256 GB or 1 TB of hard disk. Why not increase my RAM size to 1 terabyte itself? That is my first question. And second question would be, if you had to share data with someone else, why store it in an external device? What if it is directly connected to the network and I directly do a transfer to the person, or do an FTP of the file, or and directly transfer it through the network without storing it anywhere else?
The basic thing of working of a main memory is, even if it lost the power too, then also it can save some amount of data.
Okay.
So the main memory costs very less, like very less amount of current, power.
Okay.
If we keep like 1 TB for the main memory, then it costs more power. So even so, that not going to be work. That's the thing, I guess.
Okay.
No, and it's not my guess. That's my answer.
Okay. Any other answer?
Um, I would say like when we use a program, like we don't need to load like entire program because we use like certain parts. So also like main memory is very faster, like it's different ways.
Hmm. Okay. Okay. Uh, so if you look at this main memory, that is RAM, if you switch it off, you could say that, it loses all the data, but we today have RAMs that can retain all the data even when the power is switched off. That's one. Second thing, if we think that, having an external device would save on power rather than having 1 TB of RAM, it's not really true. Uh, the actual thing is RAM can can be made. We can have a RAM of size 1 TB or even 50 TB or whatever. We can still have it. It can be designed like that. But the reason that we have, we store all the major data in the hard disk and later take it back onto the main memory and then do all the processing is because main memory costs a lot, whereas hard disk is much cheaper. How much does say a 1 TB hard disk cost in US? And
Here,
compare it with say 4 GB of RAM. Probably the prices of 4 GB or 8 GB of RAM is comparable to 256 GB to 1 TB of hard disk. So if you see, the cost of RAM is too high. So what we are trying to do here is trying to bring down the cost of the computer, right? Um, uh, do you agree?
yes.
Yeah.
Okay. So what we are trying to understand here is when we are trying to engineer these systems or build these systems, it's not just about trying to make it faster or trying to make the power consumption less. There is also a cost element involved. So, um, the main reason for us for having this main memory, a very small main memory, compared to the hard disk within our computer systems is because the cost of main memory is high. And if I had to have 1 TB of main memory, the cost of a computer would go up maybe 50 times of what is the current cost. So my laptop would cost 50 times more and I would not be willing to pay that amount. And but it comes with a little bit of, you know, the processing speed will be a little bit slower, but I'm still okay with that. I'm still okay with that. This is a very important point here because today if you look at the whatever is happening on the database side, have you heard of systems like SAP HANA? Have you heard systems, database systems like SAP HANA?
Yeah.
SAP HANA,
I couldn't get the name. What's the?
SAP, SAP is a product company, and
Oh,
HANA,
SAP. Yes.
yeah, SAP, they have come up with a system called HANA, which is,
Oh.
which is the latest data analytics solution. And the whole of the HANA system, be it in terabytes, it runs on RAM. And they are able to do that because the prices of RAM have come down, because of the economy of scale with a lot of, you know, lot of customers out there. If they have in their data center, they just procure so many RAMs for um, all their customers, they'll be able to reduce the cost of the RAM, per GB RAM, whatever they are paying. Apart from that, there are a lot of other stuff in that, but that is one thing that you have to keep in mind, that the main memory, apart from main memory, we also have cache. So if you're storing it in cache, it will still be faster, right? But then we're slowly, even the databases are slowly moving towards the computer system. Oracle resides on the hard disk. Oracle database resides on the hard disk. But even Oracle has a database today which runs in memory. So these in-memory databases are kind of new innovations on in the database side. We could touch upon it a bit later. Let's move on. So I have just put it as a separate slide. So since this, okay, now the question is, the CPU is the brain of the computer system. Why do you need an OS? Why do you need an operating system? CPU is doing everything for you, right?
OS OS is the heart of the computer system.
Okay, okay. All right.
What I mean is the OS will just we can interact with the CPU.
Good. Right.
So it's like interface between the CPU and user.
Right. Their answer is correct. So the OS is something like an interpreter between the user and the CPU. So is it not possible for me to directly talk to the CPU? Will I be able to directly talk to the CPU? Will I be able to directly interact with the CPU?
No.
Can you do it like by code? Like,
Did you have something like 80, 85, 86 programming in your computer science engineering syllabus?
0 and 1. But CPU understand only 0 and 1. So
Yes, that's right. The CPU understands only zeros and ones. And if you have to directly interact with the CPU, you have to interact with it through its instruction set. Every CPU has its instruction set, 80, 85, 86, Pentium 4, or the Core i7. Every CPU has its own instruction set, and talking to the CPU using the instruction set is a cumbersome process. It's a cumbersome process. We can't just keep talking zeros and ones. It takes a lot of time to program. And what would happen, say, even if you did that, say for you wrote, for an Intel Pentium 4 processor, you wrote a program using the instruction set of Intel Pentium 4. You have one more problem there. What if tomorrow Intel comes up with Intel Core i5, Core i7 that it has come up with? You have to rewrite all your software again. Now the question is, how many times will you be doing that? So every time they release a new processor, you have to write your software again, because all your software is in zeros and ones, and that particular zeros and ones is in the instruction set or the language of the CPU. Every CPU has its own language. It understands only a set of mnemonics. Right? Do you agree with me?
yes.
Yeah.
Okay. Just let me know if it is not clear, because we are coming to, uh, because these concepts are important. Okay. And OS is the interface. Now, An OS, an operating system, is an interface between the user and the CPU, right? Then why would you need a programming language? We are all ready. I can log into my Windows system, I can write a file, I can do so many things. And why do I need a programming language? Any guesses? We're all here to learn a programming language. We are all here to learn Java. And there are other options that we have. Why do we need a programming language?
Is that programming language like compile our higher level instruction into 0 and 1?
Uh-huh. Right, right. So, though the operating system can do a lot of functions by itself, there's still a lot of functionality that is specific to a particular user or a set of users. Say, for example, I need to access my banking system and I want to, transfer some amount from one person's account to another person's account, or from my account to someone else's account. How will I be able to do that using just the operating system? You don't have all the functionalities within the operating system, and that's why you need another programming language to write that extra set of instructions, which is again, so to write that program that would do, you know. So the answer to that is, how would you add the functionalities to the software that is not already available in an operating system? Okay, now we are coming towards Java. Okay, now we have a programming language. We have so many programming languages already. We have C, we have C for procedural languages, right? So we have C for procedural programming. We have C++ for object-oriented programming. Why, again, one more language? Why Java? Any
So you
idea?
can write it and run anywhere.
Okay.
That is called platform independent.
Mhm.
Yeah, Java
Okay.
is platform independent.
Yes.
Java is secure,
Right.
and Java is used to, like mm, to write the program on the server side.
Right, right. Actually, you have brought up the two most important points here. When it came to C++, though C++ was an object-oriented programming language, it was not platform independent. Now, as we saw that every CPU has its own instruction set, we it's also that every for every other platform you would have to write a new C++ program that would be compatible with it, which is not the case for Java. Java is something that you write once and run anywhere. So let's look at the compilation process for non-Java programs like C or C++. You have something called the source code, which is the programming language instructions that you write. So you write your code, and that is what the programmers write. Okay, and then you have compilers that compile this source code into object code. Okay, and this object code is nothing but the binary instructions that talk directly to the CPU or through certain already available functions of the operating system. Okay, but the source code is converted into the object code, which is and the object code is the binary instructions that your CPU can understand, that your computer can understand. Okay. So, if you see, the source code is compiled directly into the object code. Now, what would happen in C++, languages like C and C++, is something like uh, you would have written the source code and compiled it for a particular machine or for a particular platform. Now, when I say platform, any idea what this platform stands for?
Um, could that be Windows platform or Linux is going to be different platform?
Hmm. Yeah. So you could say the operating system is the platform, but the actual definition of the platform is nothing but whatever you're standing on. Say if you're standing on a railway platform, that platform is the railway platform. And what is this C program running on? It is running on top of the operating system as well as the CPU. So it's a combination of the operating system and the CPU is what gives you the platform for a programming language. Okay, so for C and C++, the platform would be, or any other programming language, the platform means combination of operating system and the underlying CPU. Okay, so for a specific platform, you would have to compile it once more. So if you look at C and C++, if I compile it already for Windows on top of Intel, I would have to compile it again for, say, something like a Solaris machine. Okay. Is that clear?
Yes.
Okay, so if you write code using C and C++, it is not portable. That's what we say. It's not portable. But if you write it using Java, it is portable. Now, how does that happen? How did the designers of the Java programming language do this? And the second question, when C++ was already there, why did not they build that feature into C++? Okay,
Uh,
let's move on. So if you look at the history of Java, um, the first thing that drove them to to come up with a new language like Java is, you know, not just because C++ was not portable. There was something called intelligent home appliances that you actually see now. We hear about Internet of Things. We hear about embedded systems. We hear about everything else that at our homes, whether it is the television or the washing machine or the microwave oven, everything has chips built in, and they are intelligent enough to take instructions from us, right? And this was dreamt of during the 1990s. And during 1990s, what they wanted to do is they wanted to put intelligence into the home appliances. Okay, and for that, what they saw is that every other home appliance that they would build, whether it is a TV or whether it is a washing machine or whether it is a microwave oven, every other uh, device there would run on a different platform. And they wanted to write code once and run it on any platform. And that is why they designed Java. They came up with Java. Now Java, there was a team called Green within Sun Microsystems, and they came up with this thing called Java, this a language called Java, which was supposed to be extremely portable. But let's see that, how did they actually, I put in notes here for you to refer to it later, but I'll explain it to you in a diagram out here as to how the compilation process for Java programs is different from C or C++, and that is how it resolves the portability issue. If you look at Java source code, um, if you remember C++ source code, the C++ source code was directly compiled into object code, whereas in Java, the Java source code is not directly compiled into object code. It is converted into or compiled into something called byte codes. Okay, this byte code is then again interpreted, or you can say translated. Let's not go into the details right now, but it is translated by something called the JVM. The JVM is the Java Virtual Machine. Okay, and this is an important concept even for interviews. JVM It stands for the Java Virtual Machine, and it translates the bytecodes to object code. We'll see what these are later, but let's try to understand the concept. The Java source code which you have written, the actual code that you have written, is compiled into something called bytecodes. And these bytecodes are then distributed across to wherever it should be running. These are the executable files. Okay? These bytecodes are later translated into the machine language by the JVM, the Java Virtual Machine, that is installed separately on these different platforms. Say you have three different platforms, our Solaris platform, a Windows platform, and some platform number 3. Now, you have three different JVMs also installed on it. This is a JVM for Windows, a JVM for Solaris, and a JVM number 3. And what would be you be doing is you will be writing the source code, the Java file, which will be compiled into bytecode. The bytecode is also called a class file. This class file is then distributed across to all these three different platforms. And all the three platforms can run it because they have their own JVM which are translating these bytecodes into the object code that is required. Is this clear?
Yeah.
Okay. So this is what makes Java portable. It is the concept of Java virtual machine which translates the bytecodes into object codes that makes Java, all the Java programs portable. So you just write it once, then it will run on your server, it will run on a client, it will run on a browser, it could run on any computer that has a Java virtual machine run. Now, there's a question here, how can bytecode be run on any type of a computer, right? And I already told you the answer that it is because there is a separate JVM or a Java virtual machine that is uh, interpreting the bytecode for that particular platform. Now that means that you have to write a separate JVM implementation for every platform. Do you agree with that? Are you following?
Yeah.
Yes.
Implementation, I mean, like we have to, let's say for Windows, we install the JVM, right?
Yeah, we install something called a Java Runtime Environment, a JRE.
JRE.
The JRE is nothing but an implementation of a JVM.
Oh,
The JVM is a concept. It's a virtual machine on top of your operating system, and on top of it your bytecode sits. So the bytecode is then interpreted into whatever the operating system or your CPU will understand. That is what your Java virtual machine will do. A JVM implementation is a JRE. A JVM for Windows will be a Windows JRE. A JVM for Solaris will be a Solaris JRE. So there are different JVM implementations for different platforms.
Okay.
Yeah. Now, if you look at this interesting thing that happened historically, Sun Microsystems came up with Java. Why did it come up with Java? To resolve the issue of portability. Why did it want to resolve the issue of portability? It is because this issue of portability they still had because they had to make their code running on different intelligent devices like the microwave oven and the TV and all that. But then something happened. The Even though it could work, the home appliance software were dried up, which means that there was no requirement of home appliance software in the 1990s. Today we have. Today we have embedded systems for every other machine. But in the 1990s, the requirement for those kind of, that kind of code for every other machine that we have in our workplace or at home was not required. So there was no business requirement. Even though the technology was there, there was no business requirement for a code to run on multiple home appliances. This could have killed Java in the 1990s itself because there was no requirement. See, one interesting thing that you have to understand here is that technology-wise, we may invent a lot of things, but unless there is a requirement for it, it will not pick up. The radio FM, how many of you listen to radio FM? Do you? Or just YouTube?
Sometimes, uh,
Yeah. But this FM technology, it was invented 50 years before it was actually used. The person who
oh,
invented it died trying to make it popular, trying to tell everybody that frequency modulation technique or radio FM is the best way of, broadcasting through radio. But because of a lot of politics, they did not let it become popular, and it took 50 years after his death for them to implement it. Luckily, it was not the case for Java. Though there was no business requirement from the home appliances side, 1992 the World Wide Web Consortium was formed and the internet picked up. Till 1992, people didn't know there was something called the internet. There were only a few secret agencies, few defense organizations, few government agencies around the world who used to have their own intranets that had computers connected through that. But the internet, the concept of internet came only after 1992. It was in 1989 that there was one scientist who was working in CERN. His name was Tim Berners-Lee, CERN in Switzerland. He came up with a research paper saying, we want to introduce something called the internet. We already have machines that are connected in our lab. We want to connect it to another lab in other countries like Japan and India. Now, for them to be able to connect their own intranets within their countries to other intranets in the other countries, he came up with a concept called the internet. And the internet picked up in the 1990s. After 92, we know today we can't live without the internet. I'm talking to you through the internet. It all seems to be magic. Before 1992, this was not possible at all. But then because of the internet, they wanted to write some server-side program that would be able to run on multiple platforms, and that is why Java survived. Though, so the initial intention of Java working on these kind of devices, on these kind of home appliance software, was though that did not work because of the internet, because of the arrival of the internet, Java became popular. Okay. So let's move on to that was a bit on the history of Java. So let's move on to the different features of Java. One thing is that it is very simple. Okay. And when compared to C++, how many of you have already coded using C and C++, at least written some small program?
Yeah,
College,
college.
yeah.
only in college.
Okay. Yeah, even that is okay. So if you see in C and C++, there are concepts like multiple inheritance. Okay. There's a concept called operator overloading, which means that if you can have an operator and you can give the same operator, say something like plus or multiply, you can give the same operator multiple functionalities. So you can overload that. You can do multiple inheritance, which means that one class can inherit from multiple classes. So there are some concepts which should not have been there because it causes a lot of confusion to the programmers, and then maintenance is if you have to write the code once and just let it run, it's fine, but tomorrow you have to maintain the same code and it becomes a maintenance nightmare. Second thing, go-to statement. That was also part of C++. This go-to statement was eliminated. There is no concept of go-to statement in Java. Go-to statements are not at all appreciated because you are going through your right, your code is executed, and at a particular time there's something like go to this particular statement. It just jumps from one point of execution to the other, and that, if there are too many go to statements, you'll not be able to trace, what is happening in the code. So tomorrow, if there is a small bug within, say, a few thousand lines of code that you have written, you'll not be able to debug it easily because of these go-to statements. There won't be any structure. It is difficult to maintain. In C and C++, you also have something called header files. These header files, that concept is also eliminated because it's just, additional code that you are writing. There is no concept of pointers. Again, the concept of pointers is eliminated in Java because, it causes security issues. When If you look at the second last point, automatic garbage collection. Does anybody understand what garbage collection is? Okay.
It's like something that, let's say we used a variable and it's not used anymore, so the memory space being released, something like that.
Yeah, that's correct. So say you have written an object and you have instantiated that object. That object consumes some space in your memory, right? So after you have processed, after your program has finished running, what happens to the object that is still residing in memory? It still resides in memory, and it is still consuming memory even after its work is done. That is called memory leak. That causes performance issues. That is called memory leak. Now, in programming languages like C and C++, if you allocate a specific memory, say for an array or something, you have to also deallocate it. But in Java, it is taken care of. In Java, garbage collection happens automatically, which means that once the object is done and it runs and its work is over and it is still residing in memory, there is something called a garbage collector which is run by Java. It goes and cleans it up. It takes that, it deallocates that memory and frees that memory up, so you have more memory available. And then the last point, a rich set of predefined classes, which means that, whatever you want to perform, most of the classes have already been written. So most of the time what you would be doing is you would be searching the API. When I say API, it means the already available functions or whatever you understand right now. It's like it's a library of classes where you can say you want to do multiplication, it is there. You want to do string manipulation, it is there. You want to do some sorting of something, it is there. You have a collection, you want to use a particular collection, say you want to store all your data in a map, you have that kind of a collection. Or you want to store whatever data manipulation you want to do, most of the data manipulation has already been written as to how to do. All you have to do is store your data in the right data structure and then use the right, function on that, which has already been defined in the classes in the library. Okay, so you would not, most probably you will not have to write your own code unless there is something specific. Okay, all you will have to do is call the already written code. And then the second feature, the most important feature, is object oriented. Java is object oriented. Okay, so one question here, what is the meaning of object oriented or object oriented programming? Any idea?
No.
uh,
You have to define everything as a class, which is like a blueprint of like, I mean, how you want it to be, and then create an object out of it.
mhm. Okay, all right, yeah, it is like that. But any idea of why not procedural, not functional programming or procedural programming? Why not? Why not simply define functions, and why do you want to do object-oriented programming? We'll look at it. We'll look at it a bit later. But object-oriented programming is just what you said. So everything that you write is in terms of classes and objects, and that is how even we view the world. But let's get back to object-oriented later. And then Java is a robust programming language. One thing, automatic garbage collection, which prevents memory leaks. You understood why if you don't have automatic garbage collection, you could have memory leaks, right? Because you have to deallocate your memory in your code. And if you forgot to write the code for deallocating a memory for an already used object, then that object will still reside in memory and it will keep consuming that memory. Okay. And then it is, it's completely robust. I think instead of going through these points, you will start understanding it once you start writing code. But there is a lot of compile time and runtime checking, so it's like almost impossible for you to go wrong. You will find, to go wrong means before a bug becomes a defect. A bug is something like you have written some code and you don't know that you done some mistake there and it goes wrong somewhere. But if you catch that bug before it goes to your customer, it's called a bug. Once it goes to your customer and then the customer catches the bug in the software, it's called a defect. So before a bug becomes a defect, you'll be able to catch it. You'll be able to catch whatever wrong you have done in your code. It's very difficult to go wrong when you're writing a Java program. Okay, because it's beautifully checking compile time. Whenever you're building the code, things will go wrong if you have, not coded it right. And there is a lot of type safety of data. In some other languages, like there is no properly defined data. You can compare a boolean with a zero. If you look at JavaScript language, if you say 0 is equal to false, it will return a true because it thinks 0 and false are the same. You cannot do that with Java. With Java, you have to ensure that whatever data you are comparing are the same data type, so you cannot go wrong. But when you are doing JavaScript programming and you are comparing, you can go wrong, and it is sometimes very difficult to debug as well because JavaScript is a very sloppy language. It's not well written. It's not well written. And object-oriented exception handling is also great. We'll look at exception handling later, but say for example you are dividing two numbers and if you do a 2 by 3 you should get the right decimal whatever you get. If you do a 1 by 2 you get a 0.5, but if you do a 1 by 0 you should not get, it should throw an error. Usually calculators throw an error, but within a Java program you can catch these kind of exceptions, right? So you can catch these exceptions and throw a good user-friendly error message to the user saying, please don't enter, don't try to divide a number by 0 or something like that. So uh, you can handle that exception and you can provide a good error message to the user. So that is the advantage of using Java. We'll be actually doing all this. Okay. So don't worry if you're not able to completely understand, but try to understand the the concepts over here. And then the features of Java. It's architecture neutral. Yes, one. It is like write once and run anywhere. Well, it is almost true. Why almost true? Probably some other day I'll explain. But you can assume that you write it once and you can run it anywhere. And this is what I had explained. Your Java code, which is your .java file, goes to the compiler. The compiler converts that into the Java bytecode, which is the .class file. Okay, and that bytecode can be distributed to multiple systems. So you have a Solaris, a Windows, a Linux, different workstations, and it will work on all of them because they have different JREs that can translate the same bytecode. The JRE is nothing but the implementation of JVM. Okay. Any doubts here?
We're good.
Okay.
Good.
Okay. Am I going too fast or too slow, or is it the pace okay? You can let me know.
Yeah.
Okay. And then more features of Java. It's pretty powerful because there are a lot of things that you can do with it. For example, you can do networking, which means you can do TCP/IP communication. You can do socket programming. You can send packets to some other computer through the internet, and you can receive them. You could do. It has the concept of multi-threading. Anyone knows what threads are? What is a
Uh,
thread, or what is a process? What's the difference between a thread and a process?
A thread is a small piece of process.
Okay, okay.
uh,
Anything else?
I would say like in real life example, like let's say when we do a transaction using our ATM card,
Hmm.
I think like in that scenario, we would probably like execute only one thread, not do multiple.
Hmm.
To
Anything
share
else?
my
Have you heard of multi-threading?
Yeah.
Okay. See,
suppose you want to access the same by
Same.
multiple persons.
mhm.
So in that scenario, for each of them, a thread might be running on the background so that it doesn't mess up, especially in transactions and things
Transaction.
like that, where
Yeah, you're close.
parallelly.
Yeah, you're close. But okay. Um, we'll look into when we look into multi-threading. We'll look into this. I'll also give you a project around multi-threading. Um, but yeah, you just look at it something like something like parallel processing. Threads would be used for parallel processing. Now, when you see a program when it is running on your computer, it consumes some memory and it consumes CPU time. And if you want to run multiple processes, it has to run either one by one, or if it runs on a multiple core CPU, which is like a dual core CPU or a quad core CPU, a dual core CPU could run two processes at a time. Now there are more concepts to it. There are a lot of exceptions there. But yeah, but if there is one process running, it could have multiple threads. So there could be multiple threads that share the same memory space and CPU and the CPU, and they run at the same time. I'll explain this concept neatly when we come to multi-threading. If I touch that concept now, it will take half an hour more. Okay. Then we also have distributed objects, which means that you could have objects in multiple servers, and then one object could, communicate with another object. It's like, and then database access. You could write a server-side code to, retrieve data from a database and then push it back to the database. Now you could do some graphics, though Java is not so well known for graphics. It's still there. Data structure library. It has a beautiful data structure library, but if you look at the higher end applications, you still are short of data structures. But the basic data structures are there. The collections are there. Then serialization. Any idea what serialization is? Have you come across this
No,
concept?
no.
Okay, serialization means, okay, it's like, say you have an object, or say you have a string, which is nothing but your name, okay? my name is Pawan. Okay, so say I want to send my name Pawan through the network. Okay, then how would I actually be sending it? It is still going as zeros and ones, right?
Yeah.
So serializing is actually converting this object, which is name colon Pawan, to zeros and ones in a way that it is received on the other end as also Pawan. Okay.
Okay.
So if you have a Java object and you're trying to send that, transmit that object to some other, location, you have to serialize that object and send it and deserialize at the other end. Serializing means whatever object you have, you convert that into bytes and send that byte stream to the other place. The same serialization you will have to do if you have to store an object in memory. Because even when it goes and sits in memory, it sits on zeros and ones. So serialization is a concept wherein you would actually be converting your Java objects into byte streams in order to be able to transmit that object or store that object. We'll visit this later, but all these concepts are giving an overview of whatever you will be learning in the next few days. Okay. We'll be seeing how serialization is done. And then we also have the concept of digital signatures, which are also supported by Java. And then the most important thing, as all of you said, why you want to learn Java, because there's a lot of demand in the market. And as you can see, it shows up in the graph here. I picked up this chart from a reliable source where, it's an open source community where people just code using everything and then they try out their projects in that open source community, and we can see that, there has been a fight between Java and C as to who takes the first place, and I think, the Java, C and C++ together, they are, at the top since 2002, and Java has been leading in terms of popularity. Okay.
Okay.
Yep. And then we also already said that it is distributed. It's used for distributed programming, which means that you can write and run the code on the servers, and that code can also be distributed onto the clients, and again the clients can also run those. So we'll also be looking at web services. The concept of Ajax also comes in this particular distributed concept. And then multi-threaded, we already saw when we saw that Java is a powerful language. Coming to the last slide of introduction to Java, we have three different major Java editions. We have a fourth one, which is not used so much. But if you look at the top three, it's Java Standard Edition, which is the edition that you would use to work on your desktop. And then you have Java Enterprise Edition, which is nothing but the edition that you use for server-side programming, for server-client interaction, for internet programming. And then you have a Java Micro Edition, which is Java ME, which is the Java that you use for writing programs that run on mobile phones. Now, if you look in terms of popularity and in terms of the job market, the Java Standard Edition and the Java Enterprise Edition is what you should be focusing on. When it comes to mobile device programming, there are a lot of other technologies that have taken over. Java Micro Edition is not the most popular when it comes to mobile programming. Say for Android phones, you do Android programming. For iOS, you use iOS, and then that depends on whether you want to do native programming or hybrid programming, or you create responsive mobile applications or responsive web applications. So it depends on a lot of that. Java Micro Edition is not as popular as the other technologies that are competing with it. So the focus of this training will also be Java SE and Java EE. So we'll start off with Java SE, which is the desktop edition, and then we'll build on top of that, and move on to Java Enterprise Edition, which is JSP, Servlet, Spring, Hibernate, and all that. Okay.
Okay.
Yep. And that was the first part of today's thing. And after this, now what we'll be looking at is how to set up your environment for Java development, and then we'll be looking at some object-oriented programming concepts as to what object-oriented programming is and what are the most important concepts in object-oriented programming. Okay. Yeah. Do we have any questions before we move ahead?
No, we do not.
Okay. So if you don't have any questions, then I can ask questions, right?
Yeah, you can.
Okay. Um, let's see how much you understood. What are bytecodes?
Which is like ones and zeros.
Okay.
The source code is converted to bytecode,
Okay.
object code, and then object code is converted to bytecode.
Is it? Okay.
Um,
Is it
source
right?
code,
No,
the
it's the other way
compiler
around.
converts the code, and the JVM converts the bytecode to the object code.
Yeah. Right. Let me open that up again. This one. Now,
Mm-hmm.
so the Java source code, which is the .java file, is converted into bytecode, which is the .class file. Okay.
Okay.
So the Java source code is called a Java file because it ends with a .java extension, and the bytecode is called a class file because it ends with a .class file, .class extension. Now these .class files are packaged and they are sent to whichever machine that we need to be running this code, and there we have a JVM translator, or its specific implementation of a JVM is called a JRE, right?
Yeah.
So that JRE would be converting that bytecode into object code. That object code is nothing but the machine level language, the zeros and ones, which you'll be able to run on that machine. You can call the bytecodes as executables, but they're not exactly zeros and ones.
Okay. Object code is zeros and ones? No.
No, they're not. They are
So then
class
what
files.
is the use of object code then?
Yeah, it is, the source code is nothing but it's, if you look at any .java file, it is written in a language that is friendlier to you,
Yeah.
and it consumes some amount of space and all that. Bytecode is an executable file which can be executed by the JVM, and it is much shorter and in a language that is understandable by the JVM. So it
Okay.
is compiled and it is, before distributing it, you would want to make it, shorter, consume less memory. And if you would have written, the compiler is intelligent enough to even tweak your code and improve the performance of your code. So it will do all that performance tuning and then it will create the bytecode. These bytecodes are then distributed to the JVMs.
So what I mean is bytecode is of zeros and ones, right?
It's Actually, if you see, every file is zeros and ones, but what I mean to say is that bytecodes are not exactly the zeros and ones that the CPU understands. When we put something like the zeros and ones that the CPU understands, it's the object code. So the bytecode is not the object code. The bytecode is an executable file. Executable means it can be executed by the JVM. It is translated by the JVM into object code. The object code is what zeros and ones that we usually see in textbooks.
Okay.
The bytecodes are not zeros and ones. They are executable files.
Okay. Okay.
Now what we usually see zeros and ones we see in textbooks, right? Where they put 0, 1, 1, 1 or something like that, and they call it
Yeah.
machine level language. When
Yes.
I say machine level language, that is the object code here. That is understandable by the CPU. The CPU can
Okay.
understand the machine level language and it can directly execute it. So those are called executables there. Here, when I say bytecodes are executables, they can be executed by the JVM.
Okay.
Okay. Otherwise, if you see, actually every other file that you have writing is, in the end, it's zeros and ones. But it is not those zeros and ones that your CPU can understand. So the
Okay.
Java source code is still, it is stored as zeros and ones only. Even if you go to the hard disk and see, it is zeros and ones. But when you read it, it is, you can understand that source code. And what after the compiler compiles the source code into bytecode, the bytecode is also again zeros and ones only when it is stored. But that those zeros and ones are the ones that the JVM can translate or the JRE can translate. And after
Okay.
it translates into object code, again it is zeros and ones only, but those zeros and ones are the ones that the CPU can understand.
Okay.
Any other doubt here?
No,
Mm.
that's fine.
Okay. So finally, just understand that these zeros and ones are the is how anything that you interact with the computer, even if you're saying a Word document, finally it has to go and get saved as zeros and ones. So instead of using zeros and ones when you are communicating, use source code, bytecode, object code. Object code is the actual machine level language. Bytecode is the language that the JVM can understand. And source code is the language that you can understand. Okay. So, what was Java initially designed for?
Java was initially designed for work with
Home,
intelligent home appliance.
home.
Okay. Yeah. So, to work on multiple devices, intelligent devices. But then, did that solve that issue? Was it used for that?
No. Then later they used for web services. www.
Okay.
World Wide Web.
Yeah. Web services is different.
Okay.
Um, I'll come to web services when we cover that. But anything that runs on the web is not called web services. Web services is slightly different. It is something like, if a particular program is running on a particular server, why would you want to run the same program on a client as well, or on your machine, right?
Okay.
So, say a server is doing some kind of an analytical something for you, okay? Then you try to access that particular service from your program on your server. So it could be server to server interaction or client to server interaction, but you are trying to use the services of another server for just a part of your work. That is a web service. Not every
Okay.
not every application that is running on the internet a web service.
Okay.
But that will be clear. That will be clear once we we'll have to look at the other things as well. We'll come to web services later. Okay. Do you guys need a break or should I continue? Do you need a
It's
5 minute
okay.
break or something
Mm.
before I continue with setting up environment?
Yes, probably take 5 minutes break.
5 minutes and then
Come back.
we'll.
Okay. Then let's meet in the next 5 minutes. Yeah.
Okay.
Okay. Yep.
Hello?
Hello.
Okay, okay. I just okay, sir. Nothing, nothing.
I'm here, so you could ask me if you have anything.
Nothing, sir. I'm just having some noise from you, I guess. That's the only problem. It's not clear. That's the only, like the noise is coming from your side, I guess.
Okay. Actually, I think the noise is not coming when everybody is muted or something. Is there a lot of noise? Actually, I don't hear that noise. There is
So
some
the thing is,
slight.
when you're talking, it's not coming. I mean, when you're talking, you can't hear that.
Uh-huh.
Uh, but because when also I am talking, I'm also unable to hear that noise. But the thing is, we are able to hear that noise.
Okay. Because actually, even when you are speaking, I'm not able to hear that noise.
Yeah.
Am I,
So
is it some kind of sound? But are you able to hear me?
yeah, I'm able to hear you, but with that noise also.
Okay.
Yeah. We'll see tomorrow or after tomorrow what's
Yeah.
going to happen.
Okay. Yeah.
Okay. So did you had your lunch, dinner?
Yeah, I had it early today.
Okay.
How about you? You had your
Yeah, yeah, I had my
breakfast,
breakfast
right?
early before 9:30.
What time is it there?
I was like 11:10,
Okay. Okay.
11:20. It's
What
like 1.5 hour
what time do you
difference.
have? What time do you have your lunch?
And lunch generally we will have at 12 because like right now I'm with my sisters.
Uh-huh.
So generally we do have like 2 or 2:30
Okay.
generally. It won't be happen like just like in India 12:30
Mm.
lunch and 9.
Mm.
Yeah, that's what how it goes.
Okay. Okay.
So Pawan, like is like learning Java is easy. I mean, able to code and all, understanding all those
It's easier
things.
than other languages. One thing
Okay,
is that everything is set, the stage is set, but what can become complicated for you is that there is already a huge set of libraries and functions. It would take time for you to understand which function to use where, which class to use where.
okay,
But whatever important classes you have and important collections and all that, I'll be able to introduce you to that. And then I will give you a project as well. And when you
hmm,
finish that project, and I will help you finish that project. When you finish that,
okay,
you'll be able to understand how to, actually go through the library and understand what are those classes and which one to use, where to use, and finish the project later.
okay,
So that's how usually when you are trying to program with Java, if once you understand the basic Java language, what is left
mm-hmm,
is understanding the API, what are the different classes out there, which is the best one to use. And that
okay,
keeps changing continuously. Today we have Java SE 8. Tomorrow I think next year we'll have Java SE 9. So that is a version.
okay,
So every other year they add more classes based on the
okay,
requirements. So you have to keep looking into the API to see what has changed. They
okay,
also change certain features in the Java language as well. So that this
okay,
is something that you have to keep upgrading. So being in technology is always about keeping yourself upgraded, learning new things.
mm-hmm,
So you have to be, as long as you can continuously keep reading, you'll look good in technology.
okay,
But it takes, it's like this, like whatever you're passionate about, you should do that. It's like if you have a passion for programming, if you have a passion for coding, or for, it need not be just be Java, any kind of coding, or just solving puzzles, I think you will like this field.
mm-hmm. We'll see. It's going to be like I have to crack it at least. I have to take some decision whether Java or not within a couple of months.
Mm-hmm.
That's the reason. Like I had a lot of fear in my mind, because if they started placing me in the company, yeah, so I should able to understand that, because understand it, I should able to write code. There's the whether I can able to sustain or not. That's all my notion is.
Okay.
Because like if it all not Java, because all my cousins friends are in this Java field.
Mm-hmm.
So they're like managers, senior managers, they're directors. Like, yeah, they're good at, but because of their goodwill only, I'm just getting this job. But I have to yeah, sustaining that. That's the only
Okay.
option, because if not Java, I have to go for Salesforce or anything else, and I have to start searching with my own, with
Mm-hmm.
my like there's nobody to help me out.
Mm-hmm. Okay.
But if
So
so, even in this Java, if I have any doubts in the future, or in the company where I'm working, my cousins can work out for me.
okay.
So, but the thing is, I have to get understand. That's the only, like, if you're sitting like that and just watching like a Tamil or Malayalam movie,
Mm.
without subtitles, yeah, that's what it would be. So I don't want to be like kind of person like that. So I have to at least get like
I think
50 or 60% of knowledge.
if you put effort for 1 month, 1 month properly, you'll be pretty comfortable with Java. It's
Okay.
not that difficult to learn. It's an easy language to learn. What will take time is understanding the new frameworks, and that too, actually, if you are going through this course, it becomes pretty easy. What will be difficult is for anybody to sit alone and try to understand what is what. Now,
Okay.
for me, if you ask, it was easier because I started off with Java 2 years after it was introduced in 1998. So
Oh.
at that time, the library was small. There were only a few classes that I had to understand. And it was pretty easy. And I have actually grown with the Java now. It's like I've seen it grow. So I understand why did they introduce what. So I can explain to you as to what the framework is all about, and then I don't see why you would have a problem as to in understanding what is what in Java. That comes easy, and you'll also start coding, and you'll also start performing in the job. What will keep you in the job still is how much passionate you are about still learning about more and more about Java.
Okay.
Are you reading? Will you be reading technical articles daily? It's like it's not about sitting for a couple of weeks and then doing everything. It's about sustaining that for years. Then you become an expert. But
Mhm.
if you sit for these 2 weeks during the training and then a couple more weeks and try to understand about Java, you will definitely be at a position where you're comfortable working. But what
Okay.
I'm saying is to sustain that. Say in Java, you can call yourself an expert after you know a few things. But then to
Mhm.
sustain that, you have to continuously keep reading. Every new year, there will be a new concept in Java. If you stop
Okay.
reading that, if you're not interested in reading that, then you will fall back. Then there is someone else who will know that who will take your place. It'll be like that.
Okay.
So continuously reading about that and all that is important here. I think in any technology field or any field for that matter, even if you are in management, you have to keep yourself updated about what is going on, the social, political situation in a particular country. Everything has an impact, right? So in any field, you have to. So you will actually need the passion. If you are passionate
Okay.
about it, you will not feel that you are working.
I had a doubt, Pawan. Is a programmer will a programmer will do like 100 lines of code every day? I mean, he'll do like coding all the. If we have like 8 hours of work in the office, will he do the complete eight or like every hour coding like hundreds of lines of code, or will he just like what to do? What is his role generally?
A programmer, again, it depends. If you are an entry-level programmer, you will be given certain specifications Say you will be asked to write a particular module. You have to come up with the objects and classes and objects you have to define, and then you have to come up with a diagram, and that too after some experience. If you are an entry-level programmer, all you will be doing is coding what someone else has already designed for you,
Okay.
which is not at all difficult. What will be slightly more difficult is you designing it as well. If somebody has already given you, like, this is the class that you have to write, this is the object that you have to write, you won't find it difficult to write that. And to be frank, 100 lines is nothing. You can go up to 200, 300 lines per hour
Oh,
or more.
okay.
It's like we could just sit on an evening and write 1,000, 2,000 lines of code. It's not a big thing. I mean, you will be doing that if it is required. But what is important is if you think probably you could avoid writing 10 or 20 lines of code and just replace it with 2 lines of code.
Okay.
So it's more
That
about
is
how good you are at that. And it's not
okay.
just about reducing the number of lines of code, it's about writing the right code, the correct code that works well
Okay.
without bugs and works as
Okay.
expected, works to the specifications. They'll give you a specification. I'll give you an assignment at the end of the day. Let's see how you
Okay.
guys will code that, yeah, or how you
Okay.
guys will design that. That will tell, how you should think, actually.
Okay.
Okay, this is
Hey,
Mohammed.
yeah,
Yeah,
Yes,
hi.
we are.
Okay, so let's get back to this then. Now we have to, set up the environment for Java development. So what do we do about it? How do we go with it? It's pretty simple actually. Mm, have you already done this, or should I be showing that to you?
Done.
download Eclipse.
You already, but okay. Anyways,
Yeah, I had downloaded and set up the environmental variables.
okay.
But I have a doubt why we have to set the environmental variables. I mean, what is the reason for that?
Hmm.
Setting all those stuff.
Okay. Okay. Then let's go through the slides then. If you want, I can show you as to how to do that. Do you want me to show, or do you just want the concepts?
Does it matter? Like, I mean, what version of
What
Eclipse or we are using, or it has to be like the same?
we all have to be downloading the same version of Eclipse, or is it fine, like whatever?
Whatever you have is fine. Any of those latest. Which one did you download?
So we have Eclipse Luna.
Yeah, Luna, Mars, Luna, anything is fine. Mars, Juno, anything from Juno onwards is fine. Juno, Mars, Luna, or whatever the latest you have. You can download that. Download the one that you have for Java EE developers, Java Enterprise Edition developers. Okay.
I have the Neon.
Yeah, Neon is perfect. It's the
Yeah.
latest. Okay, I'll just still go through those concepts. So all you have to do is download the latest JDK, not the JRE, but the JDK, and then download and install Eclipse. Now I have put in the steps. Okay. Now you tell me, what is the JRE? We have already covered what the JRE is, right?
Yeah.
Yeah. So what is the
It is,
JRE?
it is an implementation of the JVM.
Yeah. So it is an implementation of the JVM for a specific system. So the Java runtime environment is JRE is an implementation of the JVM, and that is the minimum requirement for any Java code to run on your machine because it's the interpreter, right? Now, This JRE is required on any machine that should run Java programs. For any developer, the JRE is not enough because the JRE can only run Java programs. But if you want to code using Java programs, you would also need some other tools that are used by developers, some development tools like the compiler, debugger, and all that. These are not available with the JRE. So you have to download something called the JDK, the Java Development Kit. This JDK includes a JRE plus some development tools like the compiler and debugger. Okay, and this is needed for writing and running of the Java programs. Okay, I have listed how to do that, so you can go through the instructions if you are not done. I'll quickly show you where you have to download it and how you can do that. If you if you just go to Google and you say uh, mm, Java SE download, okay. If you just type Java SE download, it takes you to a page in Oracle. Okay, this Java SE is nothing but the Java Standard Edition. This is what you need right now for studying core Java. Okay. Now you can see that the latest one is Java SE 8, update 111 and 112. You can download any of these. You have, let me click on, see, you can download the JDK, server JRE or JRE. What you need is the JDK. So you can click on download and then you have an option either to download 8 update 111 or 8 update 112. Okay, and you will not be able to click on it unless you accept. So you have to do, this is not a great user experience from Oracle, but yeah, you have to accept this license agreement when it doesn't even show what is in the license agreement. Okay, and accept the license agreement, and then you have two options here, Windows x86 and x64. Which one would you download?
Depends upon your bit, 64-bit or 32-bit.
Yeah, so if you have a 32-bit operating system that you are running, then you download Windows x86. If you have a 64-bit operating system, then you download Windows x64 version. And once you download that, it's an exe file. You just have to double click on that and it will take you through, the whole installation. Okay, for, let me go back to, okay. So once you download that, you have to just click on next, next, next. Let it install on your default location. It would be something like, I'll show you. See, if you once you download and you click on say JDK, whatever exe that you have downloaded, and you click on run, okay. Then it says, welcome to the installation wizard, and it shows you a nice wizard which will help you through the installation. All you have to do is keep clicking on next. Okay, and it says, it asks you install to C program files Java JDK 1.8.0 underscore whatever version that you have. Okay, you can change that, but I don't recommend you do that. Let it be there in the default one. Otherwise, searching for that will be a big uh, thing. And then you just click on next, and it starts installing. I have already installed that. Okay, and it says it again asks whether you want to install it there or not. Okay, and say next, and then it starts installing it. You just have to be a bit careful about a few things here. See, it says that it is successfully installed. Okay, and you can just close it. And if you look at in your control panel, if you go to your programs, you can see that installed. Okay, you have the development kit as well as the Java 8 update 111 JRE. So both the JRE and the JDK get installed. Okay, I had an earlier version of Java 8 update 91. One thing you could do if you don't know exactly what you're doing, whether what you're doing is correct or not, is you could uninstall all the older versions of the JDK that you already have, the JDK or the JRE, and install only the latest version. That will ensure that all your programs that you are running, whether it is Eclipse or anything, that use the latest version of the JDK or the JRE. Otherwise, sometimes there could be a conflict if the version that you have is too old and if some other program is pointing to that. Now, once you have installed that, the next step, I have so once you have installed the JDK and the JRE, okay, uh, what you have to do is you have to include the JDK's bin directory in the path file. Now, somebody asked as to why you need to add it to the system variables. Now, the thing is, you have certain executable files, your Java-related executable files, be it the compiler or Java runtime environment or the any of the development tools that you have over there. Your system will not know where to find it, right? Your system will not know where to find it. So how do you know whether the system knows? So if you go to your run and type cmd, it opens up a command prompt. When you open the command prompt, if you type in Java, okay, you should be able to see something like this. If you type in Java hyphen version, it should give you the version of uh, the Java version that you have installed here. It says Java SE runtime environment so and so version. This is the build. This is the Java hotspot 64-bit server virtual machine. Okay. Now, there is one more program that should also work, and which is a Java compiler, and that is Java C. That also shows that the Java C is 1.8.0 underscore 111. Now, this is a test that you have to do to see to it that Java is properly installed, the JDK is properly installed. If you just need the Java runtime environment, all you need to check is whether Java-version is there. If it is responding with the right version of Java, then it means that the Java runtime environment is installed. But if you want the Java compiler as well, then you need to check Java C-version from any directory.
When
Now,
I do the same, it says that it's not recognized as an internal or external command.
Yes, I have the same.
for
So
Java
then you
or
have
Java C,
to install.
are you getting it for Java-version or Java C-version?
Java C.
For Java-version, you are getting it, right?
Yeah, yeah.
Yeah. That is because you have a Java runtime environment that is already installed. But the JDK installation, if you have already done that, then you have not pointed to the path environment variable. How does this command prompt or this shell that is running here know that your Java compiler is in that folder? For that, what you have to do is set your environment variable. In your control panel, if you go to environment variables, you have an environment system variable called path. But be extra careful here. Please listen to me before you do any changes. This path is an extremely important system variable. When you are changing it, please don't erase any of the older values that are placed in the path. This path variable is used by the system to actually find certain executable locations. So whatever strings that you have in this path, let me open that. I'll copy whatever values I have in my path variable. I can also look into that over here. In the command prompt, if you just type path, in the command prompt, if you just type path, you will see the value of the path variable, and you can see that in my this thing I have C program files, common files, Microsoft shared, Windows Live, semicolon. So whatever I have before every semicolon is the path that the system or the command shell will search for when I put in a command here. Say when I put in Java C version or just Java C, I want it to run the Java compiler. But then it starts searching for the Java compiler. Where will it search for the Java compiler? In all the paths that I have mentioned in the path environment variable. So what I have to do is go to that path environment variable and append the latest, um, say you have installed the JDK inside C program files Java slash JDK 1.8.0 hyphen underscore 111 slash bin. This is the path that you have to give, append. Don't delete the older path, just append, just put a semicolon in the end and then append that path environment variable with the new path of the JDK that you have. But you have to put the new path of the JDK and then slash bin as well. So let me show you how I would do that. In the environment variables, I go to system variables, I search for path and then I click on edit and then I go to the end and After the last value over there, I put a semicolon and then I put my paths to the JDK slash bin. That says that inside the JDK folder that I have, within that I have another folder called bin, which is the binary files, and inside that I have the Java compiler as well. And then I say OK, and then you have to restart your command prompt. This means just exit your command prompt and restart, and then you type in Java C. You will be able to see that the Java C is now working because it is able to search for the Java compiler. But be extremely careful to not overwrite anything else in the paths environment variable. Is that clear, or do you have any questions?
I am good, Pawan.
Okay. Is it working for everybody?
No, it didn't. I just said.
It's not just the path to the JDK, but the JDK, whatever path, and then again slash bin, a backslash bin.
Why not share your screen to Pawan, Uma, so that we can assist you?
I'll share my screen.
Yeah.
Okay. I just opened it. Can you?
Not able to see yet.
Become the presenter to share. Start sharing my screen.
Are you able to share it?
No,
Yeah,
not
okay.
able to. Should I be made the presenter
Wait,
then?
I have got.
I sent one request too, so.
Change the variable?
Yeah,
Yeah.
Are you able to share now?
I'm sharing mine, so.
Oh,
Yeah, he got it.
yeah.
I get it right here.
Mhm.
See it, right?
No, just go to the end. Go to the end. Is that the end?
Yeah, that's the end. So I added
Yeah, you have to go over bin
No,
also.
you have to put a backslash bin. Yeah.
oh, okay, that's good.
Yep, that's it.
That's it, right?
Yeah.
Oh,
Okay.
sure.
Okay, again.
Okay.
Yeah, edit, right?
Edit and edit text. Now
Okay,
correct
now
the
I'll put the.
semicolon
Okay.
first.
Yeah, let me go to the end.
You have to do an
Yeah.
okay.
Now go to
Yeah, I'm copying the location. One second. Then, okay.
yeah, that's okay.
Okay. That is,
We
You
have
have
to
to you
reset
have
the
to
command.
you have to exit and again get in. Yeah.
okay.
Okay, now it's
Good
working.
enough.
Yep.
And Java C version. Okay, now it's working. Yeah.
Okay.
Cool.
So, so
I
you
have a
understood?
question, like, I mean,
Yeah.
I have a question. So when we have Eclipse set up already, right?
Uh-huh.
Uh, do we have to have the Java C version installed, or it doesn't matter? Like Eclipse take care of all of it.
It will take care of. All you have to do is you have a configuration in Eclipse. You have to set the preference over there as to which Java runtime environment you want to use or which JDK you want to use.
Okay.
Um, okay, so I'll share my screen back.
Okay.
Okay. This is, so along with this, you have other tools as well, like Java H and Java P. There are so many other Java developer tools that are available. These are command prompt tools that you can use anytime. In fact, if you want to say compile any Java program that you would have written, okay, to compile a Java program, all you have to do is Java C and the name of that Java file, and that would give you the class file. Then to run the class file, you need the Java runtime environment, right, which is Java. So Java and dot class will actually run that. I'll show you that. Today we'll do a small Java program as well. Okay. So to verify whether your JDK is installed, you have to check two things. One is Java version and Java C version. Java version is for the Java runtime environment, and Java C version will tell you that the JDK is installed. Java C is actually Java compiler. If Java C works, even the other JDK tools will also work. Okay. Next, you have to download Eclipse. Okay, and the version of Eclipse that you need to download is I'll go to, all you have to do is just say Eclipse download on Google, and it will take you to Eclipse download site, and you can download the latest one, download 64-bit, but you go to the download packages here, and if you look at the different download packages, you can see Eclipse IDE for Java EE developers. That is the one that we would need. You have one for Java developers. That would suffice if you are just doing core Java. But if you would be doing Java Enterprise Edition, JSP servlets and all that, you would also need Java EE. That's why instead of downloading Eclipse IDE for Java developers, please download Eclipse IDE for Java EE developers. It's a slightly bigger file, but it has more features for you. And then here you can choose whether your operating system is a 32-bit or a 64-bit. And you can download the appropriate Eclipse here. And after downloading Eclipse, suppose you have downloaded this one, what you would see is a zip file. So how do you go ahead and use it? So I'll just open that location. See, I'm audible, right?
Yes.
Okay. So what you would have after you have downloaded Eclipse is a zip file, which is actually, there is nothing like installation over here. All you are doing is a download. So once you have downloaded Eclipse, it's the whole application actually. All you have to do is unzip the zip file and you will get a file like this, which is, this is Eclipse Neon. Okay. And once you have, say, um, unzip this file onto this folder, you will be able to see an executable file called eclipse.exe. Okay, all you have to do is click on that, and it will open up the Eclipse for you. When it is opening it up for the first time, it will ask for, select a directory as workspace. And this workspace is the directory in which you will be saving all your files, saving all your project files. So if you do 3, 4, 5 projects, you could distribute them into different workspaces, or you could keep all those projects in a single workspace. But that is the actual location in your laptop where you will be saving all your project files. So you can specify a workspace. That workspace can just be a folder name. It will create that folder for you. That folder need not already exist. So for me it is C users T217958 slash, and I just put a folder name called workspace underscore training, and it will create that folder for me, and I say okay, and it opens up Eclipse. Okay. Uh, uh, is Mohammed there? Uma, is Mohammed there, or
Yeah, yeah.
I got disconnected. I
He
had to
got
restart the
disconnected, so
computer.
he is.
disconnected? Okay. So initially, I'll delete this project that I already did. So initially, when you open up Eclipse, all you would have is a workspace like this. Now, if you look at a basic Eclipse workspace, you will have on the left-hand side something called a package explorer. Okay, and that is where you'll be storing all your projects, and you will be able to actually, like the Windows Explorer, you'll be able to browse through your folders and open up your Java or whatever files you have in your project. And then on the right hand side, you will be able to see a little bit of your code. At the bottom, you have your console. And then similarly, if you look at Eclipse, there are so many different windows that you will be able to use. Eclipse basically works on different types of perspectives. So you can have a new perspective. You could define your own perspective. There are a lot of things that you could do with Eclipse. But the more you are comfortable with Eclipse, the more would you be able to, the faster you'll be able to code. So Eclipse is your tool. Um, it is the standard tool that is used by all organizations, and it is open source and it's freely available, so everybody would be able to use it. Okay, so so if you have that Eclipse, then all you have to do is go to Window and go to Preferences, and in the filter text, if you type Java, you have
Yeah, so
something called Java compiler, wherein you can select the compiler compliance level. This is the compliance level at which your code would be compiled. So it's like our compliance level is at the highest because because we have downloaded the latest one, so don't have to worry about that. Let it be 1.8. And then just type JDK in the search box, and it will show you your installed JREs. And this would show up by default if you already had that. If you don't have it, you know, you could add it as well To add it, you can go to add, and then you could add standard VM, and you could point it to the actual JRE home that you have, and you could point it to the latest JRE that you have. Okay. So once you have that setting, then your code will run flawlessly. If you don't have that setting, then it will start giving you issues when you are trying to compile your code. Okay. So as long as you are able to do that, you'll be able to, your setup would be complete. Your JDK is installed. With the JDK, the JRE is installed. The JDK is nothing but the Java development kit, which is the JRE, along with the tools that you need for development, like tools like the compiler or the decompiler, or there are so many other tools. We will look at it later. And then you need Eclipse. Now, when you already have the JDK with you, why do you need Eclipse? Eclipse just makes your programming easier. If you try to write a Java program just like that, and you make some error or some mistake when you're writing your code, you will not know that. Even if you have missed a bracket or some braces, if you have missed even a bracket, you'll not know. If you're just writing it in a plain notepad file or a textpad file. But if you're using an IDE like Eclipse, it will immediately point you out and say that, you have missed some braces. And it will also help you keep your code neater and indented. Okay, so that was about setting up your environment for Java development. Let's move on to the last of today, which is object-oriented programming. I think I'm hearing a lot of noise there. Um, uh, 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 think, I'm not sure from where it is, but can you mute your mics for some time?
Okay, we are going to mute our.
Okay. Okay. Now coming to the object-oriented programming fundamentals. So we have already looked into the history of Java and the different features of Java. There's supposed to be a refresher on that. Now let's look at we already saw the JDK and JRE. Now can anybody tell me what is the difference between the JDK and JRE? Just to summarize on what we saw. I think everybody is on mute.
Oh, yeah. I was talking with having the mute. Okay.
Yeah, that happens a lot of times. Yeah.
JRE is the runtime environment which is used to run any Java program. JDK is for the developers. It's like the development kit that helps us to write our code and have it compiled and
So if you install the JDK, would you also have to install the JRE?
No, the JDK itself contains JRE
Okay.
and some development tools.
Okay. Cool. So everybody has understood that. Okay. So the difference between, sometimes in the interview, if it's an entry-level interview, people do ask, like, what is the difference between JVM, JRE, JDK? Okay. All right. Now, we already saw the JDK and the JRE. The JDK also has certain classes and methods that are part of the Java standard library and certain development tools. Those development tools, one of those that we already saw that we can see over here as well. This one over here, this is the one that we already saw. That is the Java compiler. And this one we saw, this is nothing but actually the JRE, which is a Java interpreter. It's actually the Java runtime environment which can run applets and applications. Now I have not told you what applets and applications are, but I'll soon tell. Um, the JDK is also something that you already know. Now, it's not just applications that you can write using Java. You can also write something called applets. I'll tell you the difference between those two in a couple of slides later. But to be able to view an applet, you have you have a tool called the applet viewer. And when you are actually writing source code, you should always have, it's not just a good habit but a very necessary habit to document what you're writing. And when I say you're documenting, it means that at least for every method, before a method you're writing a function, write what that function does. For example, you are writing, say, a function called multiply a comma b, and which returns a into b. At least write that this function multiplies a into b and returns a into b. It takes parameters a and b, which are both integers, and then it returns this. So having that habit of writing what a method does actually, it clarifies a lot of things. You should do that for every method that you write in a class. Okay, and this Java doc, what it will do is whatever comments that you have written within your Java file for every method, or say for every class file, this Java doc, just by running this tool, you can create a manual, an HTML kind of a documentation for all the Java source code files that you have. So you can write your own, it will create an API for you, which means that it will create an API documentation for you. So if you have written a function, say multiply, and within the comments you have written this function multiply so and so, that it will, if you just run the Javadoc tool, it will create an HTML kind of a file which will have it documented saying this function is present within this class and it multiplies so and so. And that, so you won't have to do it manually. So when you are handing over your code to, say, some other developer who is going to be the user of your code, so you have written some API, you have written some classes and files which is being used by someone else. All you have to do is run this Javadoc tool and give it to him, so he will know what, which function of which class to call from your code when he is trying to use your code. So this documentation is a very important thing that you have to do. And then Java Edge, not used much, but it is only used if you have native methods within your Java code. Now within your Java code, you could also write some C or C++ code as well, or in any other native language. For native language means the language that is understandable by the CPU. So if you have anything for that any particular code that is written specifically that runs on that platform, you can also, there is a way of putting it into your Java code. This is not used much, but only sometimes. But if you have that kind of a native method within your code, then this tool can create a header file for that. Now I have a question. If you have a native method within your code, within your Java code, is that Java code still portable?
Yes, I think.
If yes, how? If no, why?
Because I think even because you're including the header files in your Java files, right? So when it compiles, it might compile it into Mm.
But
So the
actually,
bytecode,
yeah, but that's a good try. But that unfortunately it doesn't happen. Our native methods that we have, it is still native, and there is Java has at least not yet a way of translating them into a way that is portable. So if we have native methods within a file, then that is not portable. Though the rest of the code, that is pure Java, is portable. The ones that we that has native methods is not portable. And then say you have some class files, some bytecode files that you have got from say someone has already written a Java code and he has compiled it and he is just giving you the class files, okay, the bytecode files. There is a way of getting the Java code back, and that is by using the Java disassembler, which is getting the uh, your source code back from your class file.
okay.
And then you have a tool called the Java debugger. This debugger is again, it's not used much because you will mostly be coding with Eclipse. So you will not be using the Java debugger much, but there is also just know that there is a command line tool just in case you don't have Eclipse. Uh, you can still use JDB for debugging. Bytecodes and JVMs. There are a few notes that I put in the slides. You can go through them, but that is something that I already covered. This is in detail as to how the Java compiler and interpreter work. So you have a Java program, the source code, the Java compiler, which converts it into, the bytecode, which the virtual machine takes and it it interprets it into machine code, which is a real machine code. So this is the whole process. Now, let's come to the two different kinds of code that you can write, which is the applet and the application. Now, when you see in the industry a lot of people writing code, they can write two types of code. One is the applet, the other one is the application. But most of the times when they say they are writing Java code, it means applications. Applets are Java codes that can be run on a browser, on a Java enabled browser, something like say Chrome. Chrome is a Java enabled browser. Now most of the browsers are Java enabled, but they are not preferred. So during the course of this training, I can introduce you to applets, but it is not widely used in the industry. So it doesn't make us, it doesn't make sense to cover applets. But I can show you what those are. That is a piece of code that is downloaded from the server and it can run on the browser. And that made Java famous in 1996. Today, Java is not popular for applets. It is popular for applications. The difference is that applets are run on a browser or it runs on the browser, whereas applications need the JVM or the JRE to run. So when you convert your source code to bytecode, the bytecode has to be translated by the JVM or the JRE for an application to run. Whereas an applet just needs the browser like Chrome or Internet Explorer to run. Still, there are people who use applets, but it's not, even Oracle is not doing much for applets now because it's only for some small game-like applications that are, done by some students in colleges. They write applets, but in the industry, Nobody, almost 99.99%, nobody uses applets. Okay, but just know that there is something called applets also. So if somebody asks you, like, for a Java, a source code which is the .java file, the Java bytecode which is a class file, once it is converted into bytecodes into the class file and it has to run, what would you need? So you need a JRE. If you don't have a JRE, it could be an applet and the applet could run on the browser. So just remember that there are these two options. So an application runs on a JRE and an applet runs on a browser. That is all that you would have to remember.
Is there any scenario where you would use an applet over an application?
Not many enterprise kind of scenarios. Today, Java is not popular for what it was popular for in 1996. What caught the eyes of the audience in 1996 was a funny looking triangle shaped cartoon that was dancing on the browser. Around 1996, if you look at the browsers, what were the browsers and the kind of websites that they had during that time, there was not much of interaction that was happening between the client and the server. Only the kind of websites that they had was certain websites that would post some information about their, some kind of contact information, something like telephone numbers or office addresses that they would post, something like an advertisement. There will not be somebody who would be logging onto a site or posting images or anything. The capabilities were very, 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 very minimal. Um, and during that time when the capabilities were very minimal and most of the websites looked like some static information which was just like, okay, this office, this is the contact details of the person, and that is just one web page that represents the whole company. That is the kind of website that they had during that time. And during that time, what Sun Microsystems did is they introduced Java applets, which could have some kind of cartoon-like looking things that would, that would also move on a web page. And that was not something, they only had static web pages at that time. So what caught the eyes was like, "Arey, how is this cartoon like figure moving on my web page?" That was actually an applet. That was actually an applet running on the browser. But today, we all know that there are so many other technologies that can do that. So applet is not at all in the competition with anything that runs on the browser. Most of the technology that are used on the client side are, today it's not just desktop. Today you have mobile phones as well. So you use Android or iOS, or you do that kind of a programming for mobile devices. Or if you want to use pure HTML and JavaScript and CSS, you can still play with a lot of JavaScript libraries out there. So applets are not at all preferred. There is no scenario today where you would prefer an applet over anything that HTML, CSS, JavaScript can do. And there is nothing that HTML and JavaScript can't do and applet can do.
Okay.
And let's see if that. And let's see if I can still. I'm trying to look for that original, no, that original Java applet. Probably I'll show you tomorrow as to, what it does. But if you look at these Java applet applications, that they are showing over here, something like a chessboard, or something like, what they are showing is more like analytics kind of a thing or a 3D kind of a thing, you can build much faster and much better performing applications using JavaScript and CSS today. It's much easier. These are nowhere in the competition.
Okay.
And okay, uh, let's go back to this. Now, if we look at, yeah, now Java is an object-oriented programming language, right? So I think we all know about that. So we can do procedural programming, we can do object-oriented programming, we can do GUI programming, and we can do functional programming as well. There are actually 4 different types of paradigms of programming that we can do using Java. But if anybody asks, the first thing that comes to mind is that object-oriented programming language. Java is an object-oriented programming language. So first thing that we have to understand and very quickly understand is what is object-oriented programming? What is that paradigm all about? What is that thinking? Any idea what was used before object-oriented programming? Like C. C++ was object-oriented, right? Then why did they even come to object-oriented programming? Any idea? We had something called procedural programming, right? Anybody?
No.
Okay. See, if you are just, if you are given a small program, say something like multiply 3 numbers, okay? It is very easy to write a function like multiply a comma b, all right? And you're taking multiply a comma b comma c, and create an echo. Okay, thanks. So if you take multiply a comma b comma c as a function, all you have to do is return a comma b comma c, and it would return the product. It will return a into b into c. It will return the product of a, b, and c, right? And you can use that function. And the first thing that went into, all the programmers of the earlier days was like, if we classify all that into different types of functions and package all those relevant functions into a particular, inside a particular package, then it's, it makes it easier. So all they would do is have a lot of functions inside a particular package and then use it. But the problem was, say, when it came to building enterprise level applications, say you want to build an application for, say, a banking, something like a banking system, where in what you have to do is, say, for a simple application, something like transferring money from one account to another. Okay, so someone is a sender and the other person is a receiver. The money has to get debited from your account and it has to get credited to someone else's account. And all this has to happen atomically, which means that it has to happen as a transaction, which means that it has to, debiting from your account and crediting from their account has to happen together. What if something gets debited from your account? Say you are transferring $1,000 from account A to account B. What if account A $1,000 has got debited and the account B $1,000 has not got credited? You have to roll back that transaction. But then you would not know which function is supposed to do that and who is owning which account, because all you have is functions over there and there is no, actually there is no owner of that account. All your functions are doing is reading from the database, doing some manipulation, and then so it's not easy to roll back. And when you code with just with functions and you just have multiple functions, say you have written functions over functions over functions, and you say your code is now full of hundreds of functions, you will not be able to organize it in a good way. It becomes more like, noodles. It is just noodles. It's very confusing to maintain such code. And that is why, and that is when people started thinking it's not the transactions that should be the focus, it is the accounts that should be the focus. So they started moving into object-oriented programming, which is a better way of thinking about the world around us. It's we think about the world around us in terms of objects, in terms of classes and objects, and that is object-oriented programming. Now, this thing will become clear only if you code an enterprise kind of an application. Okay. Do you have any doubts till now?
You're good.
Okay. So if you code an enterprise level application, then you will start finding, coding in terms of functions is not as good as object-oriented programming. But if you write a small program, something like a hello world program, you'll feel, why should I write a class for that? All you need is say print hello world. Why should I write a class for that, create an instance of that, and then run a method and then say hello world? So object-oriented programming and functional programming or procedural programming, they have their own advantages. Object-oriented programming is better when it comes to enterprise applications, when the size of the applications are huge, are big. But it doesn't have to be very big for you to be able to identify the advantages of object-oriented thinking. Even if it is, a few thousand lines of code, you start feeling like I should have written it as objects and not as just functions. Because when something goes wrong and you have to debug it, you will not know which function is doing what, where things are going wrong. Hello? Hello?
Yeah.
Yeah. Okay. Now, when it comes to object-oriented programming, the usual question that is asked in interviews as well, and what is most important is, what are the four pillars of object-oriented programming? Okay. And it's encapsulation, abstraction, inheritance, and polymorphism. Okay. This kind of thinking, this object-oriented programming paradigm has come, you know, from how we actually look at the world around us. For example, even here in the notes, we have an example, like what is encapsulation? Now, encapsulation is nothing but hiding of the data, right? Now, the example that is given over here is like when you look at a television, right? All the wiring inside the television, the thousands of volts of shock that you would otherwise get is actually hidden inside the television, and all you are enjoying is the service that the television is giving. You're watching programs or something like that. So the data should get encapsulated within the object. The object owns the data. That data should be hidden inside the object, and it should not be something like, you know anyone else apart from that object should not be able to access that data directly. It has to go through the object. Let me give you an example. Say you have, a few lockers in a bank. You can go to a bank and you can place, any valuables in a locker, right? When you go to a bank, there will always be a specific person who will be monitoring who is accessing which locker, right? Even though it is
Right.
just you who has the key, there will still be a person who is monitoring. So you are always going through that person. You just can't go and open up any locker and just place it even if you take responsibility. So there is just one person who is responsible for the locker. So if anything goes wrong with any of the lockers, you know whom to catch. It is a person who is giving access to the lockers. This is the person who is accountable for it. It is the same view that you have in object-oriented programming as well, wherein the data is getting modified. Data is the most important thing here. We are manipulating data. It's all about information science, right? It's all about information. It's all about data. Data is the most important thing. And if you want to see who changed what data or whatever happened, you know which object did that. Because there is a particular object which is letting other objects modify its data, then you know that it is this object that is accountable. If you look at your functional programming or your procedural programming, this concept itself is not there. When something goes wrong with the data, there is nothing that is responsible for having changed that. So in a class or an object, the information or data is hidden, it's encapsulated. Now the second important feature is abstraction. Now abstraction is a concept where you apply in your daily life as well. Even here, if you look at just the example that is given here, it says that a person operating the television does not need to know how it operates from inside, right? It's only the person who is a electrician or a person who is a car mechanic should know how the car operates. But when you are driving your car, you need not know how your car operates. You're not worried about that. So that is the abstraction that we are talking about. You just focus on the parts that you need to know. Like when you're driving a car, you should know where the accelerator is, you should know where the gear is, and you should know where your steering wheel is. That's all. Do we all know how it actually internally works? We don't know. That is abstraction. And that is a very important concept even, whichever field, whether it is economics or whether it is management or whether it is whichever field, it's an important concept. It's called systems thinking. You don't actually look into the details of the system unless it is necessary. So you don't have to know the details of, say, a particular class unless it is necessary. You just need to know how to access that class. Say, for example, you want to perform, say, some kind of a string manipulation. You want to read a string, you want to convert that into a palindrome, and you want to, no, sorry, you want to just reverse that string, and then you want to give the output. Say, you say cat, you get the input as cat, you want the output as TAC. If that is what your function should do, and you already have a class and a method that does that, all you want to do is call that without worrying about how it is being implemented inside. So that is abstraction. Abstraction means your focus on is only on those parts of the object that you need and not on the implementation.
Can we say that as it separates the logic into logic so that from a class, if I want to call a function, I do not need to know about what that function does, just I want to use that function. So it's like it separates the logic. Can you say abstraction is?
It separates the implementation from the interface. That is what we call in actual object-oriented programming terms. If you look at the standard books on object-oriented programming, well, what exactly you said is called as separating the interface from the implementation, which means that uh, you're just worried about the interface but not about how it is implemented inside. Say you have a collection, you have an array and you want to sort that array in ascending order, and you have a function that already does that. All you need to call is say arrays.sort and say parameter as ascending or descending, and then it does that. You don't worry about how it is implemented internally because you have other things to worry about. Just like that. You go to a bank and you give the money to the cashier and then you say deposit it into my account. You don't worry about how he is depositing or what is the process, how is it happening. You go to an ATM, you withdraw from a bank and you don't worry about how they do the money transfer, how is it you gave in cash somewhere and how is all that transaction happening. You did an online transfer and that person immediately got it into his account. You don't worry about how that actual money was transferred, or was it transferred, was the actual currency transferred, or how all the internal process works. So it's about just looking at it from an angle at which you want. So you're taking the services of particular class or object and then its methods, and you are moving ahead with your work. And this is how you do even when you are coding. So when you are coding and you're already having an API which does something, you just utilize that and you move on, because if you just look at your work, you will have a lot of other things to do that you are doing, right? So that is the kind of thinking. So you were actually right when you said you were separating the actual logic implementation from the interface. So all you need is a method definition. What are the parameters that I have to send, and you're not worrying about how it is implemented inside internally.
Okay.
And the third one again is important is the inheritance. Now this is how uh, inheritance is the process in which objects of one class acquire the properties of objects of another class, right? Which means that it's kind of a hierarchical, way of distributing an objects. Everything that the kind of objects that we see, one thing, it inherits from the other certain properties, certain data and methods. Now every class that we define here has two things. One is the data and then the methods that operate on that data. Okay? Every class has data and the methods that operate on that data, and that together form an object or a class. Now over here when we say inheriting, one object actually or one class actually inherits from another class. So this is what we call inheritance. We'll see more of it as we code, but just understand that you have a superclass and you are deriving from that superclass. Okay, certain things. Say, for example, over here in this figure, you have something called shape. Okay, and there is something called ellipse, rectangle, triangle. These are more of implementations of shape. Now, all these three different classes like ellipse, rectangle and triangle are of type shape. So that is polymorphism, but if you just look at rectangle being deriving from shape, that is inheritance. So it is inheriting all the properties that shape has. So in the same way, if you look at objects, say it's a normal object, and say you have something like car. A car is an object. And then say you have something like a luxury car. A luxury car is a special type of car. So a luxury car could also be a class which has all the properties of a car with some additional properties. And a car could also be a special case of a vehicle. So a vehicle could be a class with a subclass called car. So a car is a special case of a vehicle which has all the properties of a vehicle with along with some other you know attributes and methods of its own. So if you code it like that, like inheritance imbibe, then it becomes much easier and you don't have to repeat yourself for every other shape. Because when you're doing this, the ellipse, the rectangle, the triangle, all of these shapes, whatever common attributes it has, are moved onto the shape class. So you're not repeating code. So the basic thing that we are doing here in inheritance is we are not repeating ourselves. We are reducing the amount of code that we are writing. I can give you one more example of inheritance and polymorphism together. Polymorphism is again, it means one interface and multiple implementations. It means that ellipse, rectangle, triangle, all the three are of type shape. So it is like one interface with multiple implementations. I'll give you some example later, but here it means that it defines a method called getArea. Now, every shape has an area, ellipse also has an area, rectangle also has an area, triangle also has an area. So you don't have to rewrite the common logic that you have for ellipse, rectangle, and triangle. All that common logic can be written just for shapes, so you are reducing the number of lines that you are writing. So the actual value of doing inheritance or polymorphism or information encapsulation and abstraction is like your code will be much neater, your thought process will be much clearer, you will know which object is responsible for what data. If something goes wrong with some particular data and it is, say, the amount that got credited in a bank account is not the amount that was debited from some other account, you know where things would have gone wrong. It is much easier to trace, much easier to maintain, and you reduce the number of lines of code that you are writing because you don't have to repeat your code for everything. All the repetitive work that you have written for a particular class it goes on to the super class instead of the subclasses. This point will be much clearer when you actually code you know, and with using classes and objects, or even when you start designing them. Is that a bit confusing, or is it clear?
It's a bit clear, yeah, but maybe I can get more understanding after writing some code and all.
Yeah, I think after we see a few examples, because we'll be looking at classes and objects in details for Java, and when we do that, things will start getting clearer. Um, okay, so if you look at the first Java application, it was the normal Hello World application. I had tried to trace who actually wrote the first Hello World application in any language, I don't know, and I never got a reply. I asked my seniors as well, nobody knows who wrote the first Hello World application. But yeah, since Hello World is the first application for any language that people write, we can look at this application and we can see how to write that with Java. For that, let's go back to our Eclipse. I'll go to Eclipse, and in Eclipse what I'll do is I'll go to new and I'll say Java project. Okay. What I'm trying to create here is a new Java project. All I have to do is give some name. So I'll say hello world. I'll say my hello world. Okay. And it asks me where should I place this project. I'm saying use the default location. I'm not changing any of the parameters here. I'm also asking it to use the default JRE, and then is a project layout. Just keep it to the default. It doesn't matter right now. I'll tell you later if you need to change it. For now, it doesn't matter. Just say next, and it says that it is trying to create that, and just say finish. Now what it has done is it has put the JRE system library here, but that is the library that your project would be using. But as part of the source file, that is nothing, right? So what you need is to do is right click on the source file, create new, and what you need is a new class. Okay, and it is saying that it will put it into this source folder. You can don't use the package right now. You can just name the class hello world. Okay, and it is asking if you need to use some other superclass. The default superclass for any Java class is java.lang.object. Okay, and there are certain things called modifiers. We are yet to cover this. Just keep it default. Which method stubs do you want to create? Just keep everything default except for you want to create public static void main. Now I'll explain what public static void main is, but just check on that, check that, and then check generate comments as well and say finish. When you finish, it says, okay, this is the author is me, and then public class hello world. It has created a class for me. There are no members in the class. I don't need any. Right now, all I would need is just a line which is system.out.println. I'll explain to you what this is. So this is going to be your first Java program. And I save it. Now once I save it, okay, Eclipse has auto created the class file. This file over here is the Java file hello world.java, and the file over here is the class file which has already been generated by Eclipse for me. See, I didn't even have to compile. And then hello world.java, I go here and I say run as a Java application. And I don't need a server here because all I am doing is Java SE. It's not Java Enterprise Edition. I'm just using Java Standard Edition. And all applications that I'm writing are Java applications. And you can see the output in the console at the bottom here. And it has output hello world. Okay. Is now all I have to say is that, see, all I have written is one Java file which is hello world.java, which has one method which is public static void main. Now I need to explain some of these things over here. Now, yeah. And did somebody ask something?
Mohammed asked, tried asking something.
Okay. Mohammed, Umar, are you there?
Yes.
Yeah, yeah.
Yeah. Were you asking something?
No, no.
Okay.
He's
So,
actually, yeah, the first
First
program.
program and it ran.
sorry, you already tried that?
Yeah, yeah. Whatever you tried, yeah, we did the same thing.
Okay. Okay. So, were you able to run that?
Yeah,
Yes.
yeah.
Okay. Cool. So, what I need to explain to you here is this Hello World program that I've written. It's a Java file. That is one thing. That's the source code. So the file that you see over here is the source code. The file that you see below that with the C over here is the class file. It's already compiled. Eclipse compiled it for me. Okay. And then this class over here, don't worry about this public and public static void for now. This hello world class over here that we have defined has only one method, which is the main method. This main method, which starts with public static void and main and has arguments like string and args, is the standard function in Java, and that is the first function that runs whenever you run an application. This project that I have today, it has only one Java file. Tomorrow, even if I have multiple Java files, it will run the file that has the public static void main function first, and it will run this function first. This is the starting point of any Java program. So all you have to remember today is that this public static void main method within any class is the starting point. So what it will do is, like, it will do public, it will take the main method, it will search for the main method and it will start executing it. And what do we have to execute over here? There is only one line that needs to be executed. And it says system.out.println hello world. And this system.out.println, what it does is it prints hello world and pauses. That is also, if I write, say, I'll just copy another line and I say system.println hello earth, say. Okay, and I save it. And now I run it again. You can see that in the console I have hello world and hello earth. Now, what you may ask is, you have already printed hello world and hello earth. When you had printed hello world and you were expecting hello earth on the same line or in the next line, how would you know? The system.out.println prints on the console and adds a new line character in the end, which means that after it prints hello world, it adds a new line character. So it's like hello world and then enter, and then you have hello earth again. Suppose, suppose I have one more function over here which I could use instead of system.out.println. If I say system.out.print, and now I save this and I run this, you can see that hello world and hello earth have got printed on the same line. Why is that so? Because system.out.print only prints what you have given to it, but it does not insert a and does not add a new line character here after hello world. So what happens is, this one prints and adds new line character, whereas system.out.print does not add. Now if you print, say again, say if you want to write system.out.println every time, you don't have to type it completely. All you have to do is write sysout, sysout, and press Control space. All you have to do is type sysout, sysout, and press Control space. It will type system out println for you. Now if I say hello universe and I run it again, now will you be able to explain why I got the output that I have got here?
Because you gave ELN in the second statement.
Yeah, so in the second statement we have a new line character. So hello earth, and then it has already in, put in a new line character, and so the next third line is that is the hello universe is there in the second line here, because after the first one hello world was printed, there was no new line character. After this there is a new line character, and after this there is one more new line character. So there are two new line characters here. Okay. So this is about system.out.print and system.out.println. We'll get into the details of system.out.print and println later, but this is a lot many times these are used for debugging. Okay, so you want to debug something and you want to, when you are usually debugging, you have the habit of printing it onto the console, right? Say something like you have done multiply A and B, and then you got to so the whole logic, you are printing at certain points you are printing the values of certain variables. So you could use system or println for that. Now, um, yeah. So that was your first Java application. Here I have explained what every uh, part of that is. Now this is a public class. I'll tell you what it means when we look at access modifiers. But all you have to understand that this is a class. Right now I'm not putting any variables there, and there is a public static void main function, which is the starting point of the Java class. So whenever you run a Java program, the first thing that it searches for is a public static void main. It searches for that and it runs whatever is inside that. So even if I define a second function here within hello world, okay, it will not run that function. It will only run public static void main. What if I don't have a main function? I save it as public static void main. Then what will it do? What do you expect it to do? What I've done is I changed this public static void main to main1. Okay. And now it says that it didn't find. See, the main method not found in class. Please define main method as public static void main string args, because this is where it starts. Every Java application starts from public static void main. If you don't define that, it will throw an error. And these things that you see over here, like public over here, these are access modifiers. This just means that this particular class is public, which means that any other class will also be able to view this class or talk to this object. And a public method means that any other class can access the public methods of this class as well. So if I have class hello world, and if I have some other class B, that class B can access hello world's public methods as well. This void is the return type of this main method. It's like this method right now is not returning anything to any other function. And this being the main method, this only goes through it only, when this Java application is run, it comes to the main method and then it starts running these lines, it executes these lines, and then when it finds this closing brace of the main method, it stops executing. So you don't have to do any return from this main method, because you know this method is not going to return anything. That's why you have the return type as void. Okay. So that's about your first Java application. Now I'll show you how to run this using, and you could do this on the command line prompt also, but probably we'll look into it later, maybe tomorrow. But it's like whatever you're doing with Eclipse, you can do it on the command line prompt as well. All you have to do is save this hello world.java in a particular, I've given the steps here, save it in one of the folders, go to that folder and do java c hello world.java. That will give you hello world.class. Then all you have to do is java hello world, and that will print hello world for you. Okay. So this is something that you have to uh, print.
We said that the main is the starting of a program, right?
Yeah.
If there is an application where there are like 5 classes involved, then we have to make sure that only one class has the main method and the other classes just have the methods and everything.
It's like when we are trying to run a particular project, okay, you have to define which class would you start execution from, right? Say in a particular package you have 4 classes with 4 main methods. All of the classes have all main methods.
Okay.
You can still tell that you want to start execution from a particular class, because you're running the application. When you're running the application, you are specifying the class that should run.
Okay.
So say you have hello world 1, hello world 2, and all of these have main methods. When you start running it, you say Java hello world, it will search for the main method within that hello world class.
Okay.
And now within the main method of the hello world class, if you are calling the any of the methods of hello world 2 or hello world 3, it will also get executed.
Okay.
And now if
Even there are many classes.
you could still have main methods, but usually you don't do that, because you have already properly defined your project and you would know what is the starting point of your project. Only there will you specify your main method.
Okay.
The other classes, even if you specify your main method, since those are not the starting points, the intended starting points, those main methods are never executed.
Okay.
But sometimes, if you just want to test that class, just only that class, just compile it and run it using the main method, you can use the main method for testing the methods of that class.
Okay.
You got that point, right? So
Yes.
you have
Yes.
hello world 1, 2, 3. If you just want to test hello world 2, you can define a small main method there and you can define whatever testing you want to do for just for that class.
Okay, that's fine. I wanted to know on a bigger scenario when there are like more classes with more main methods. So yeah, I got it. Yeah.
Yeah. So nothing is stopping you from defining main methods there, but unless you call the, run the Java program from that class, it will not call the main method for that, for any of the other classes. Okay. So, okay. Looking at we have a lot of Java controls that we have to look at. But these are pretty simple and straightforward, like if else, do, while, and we can cover this all of this tomorrow. Today I'll just introduce you to variables and constants in Java, and then we can stop it there. Tomorrow, all we'll be doing is code and code and code. So we'll be looking at different control statements, and tomorrow we'll finish off the Java language control, all the statements and if else, all the if else ladder, switch case, break, bitwise operators, and all everything that is related to just the Java language, but without the API. Okay. So today I'll just introduce you to variables and constants in Java. Now since all of you are from computer science background, I don't have to tell you much about variables and constants. You know what variables and constants are. But in Java, there is no proper way or straightforward way of saying that that particular variable is a constant. In Java, all you have is variables. But when I say there are something called constant literals in Java, it is something like, say, if I specify variable x is equal to 10, okay, then that 10 is a constant, right? That 10 is a
Yeah.
constant, but that is what I call a constant literal. It's not actually a variable like constant. I'm not saying that, see, let me open, say, in some languages you have something like variable x is equal to 10, okay? And we could also say constant y is equal to 10 or something like pi is equal to 3.14152, okay? So here, this one is actually a variable and its value can be changed later in the code. So I could assign x is equal to 15 somewhere later in the code, but I can't change the value of pi is equal to something else. Right? This is the usual behavior in most of the languages. In Java, you have no keyword like constant here. You have only variables. Okay? And in
Okay.
Java, the way you write it is say int. Okay? Suppose it is an integer. I can say int x is equal to 10. This is how it is in Java. In Java, it is strongly typed, which means that every variable that you define, you have to tell what type it is. Is it an integer, is it a character, is it a string, or what is it? So in Java, if you are saying x is equal to 10, then you have to say what variable it is. You can't just say it is just a variable. In JavaScript, you can say variable x is equal to 10, then it will take it as an integer. Variable y is equal to hello, it will take it as a string. But in Java, it is like you have to tell what it is. You can't just say where. So you have to say int x is equal to 10. Then x will only hold integers. You can later change x is equal to 20 is valid. Fine. But like in any other language, you will want to define constants, right? What if you have something like pi, which is 3.14152, or you just want to define your own constant within the language, right? In those cases, you have to define those as static and final. You use access modifiers. In this case, this behaves more like a constant, which means that when you say that some variable is final, it means that it cannot be assigned another value. That is the first and last value that it can have. Okay, I'll explain what static is later, but this is how you define constants in Java. Okay, is it clear or is it confusing?
It's clear.
Clear.
Sir, Pawan, I have a doubt.
Yeah.
So if you want to print in the above case in the 9 and 10 statements, if you want to print, if you say like system.out.println x, then it will print 20 or 10.
Here, if I print it here,
Yeah.
if I print it here, something like x is, and I can print the actual value of x. For that, I have to concatenate it with this string. It will take this thing as a string plus
Okay.
the actual value of x. Okay, and
Okay.
it will say x is
X is 20.
20.
So it automatically updates the value.
Yes, it updates the value. All you have to do is trace it. See, x is equal to 10, then x becomes 20, and then, you know. So if you
Okay.
trace it, now over here x is equal to 10. If I would have had this statement here,
Yeah. Okay. Okay. I got you. I got it.
then the value would have been 10. So first it would print x is 10, then x has become 20, so it becomes 20. So every method, whatever you write, you have to trace it like that for all the variable values. So after every statement, it has a value. But this thing here, since it is defined as final and static, it is like a
So
constant.
even if you write x equals to 20 in the 15th statement, then also it only prints 10, right?
This one here, I just gave an example. Here, since it is already defined as integer x, I should use a different value here. Otherwise, it will give an error because I am trying to declare the same variable again. A variable can be declared only once, right? So it is an integer, x is equal to 10. Here I was telling if x is equal to 10 would have been defined something like this with these access modifiers, it behaves like a constant. So if I say static final int y is equal to 10, and then now if I try to change the value of y, it will throw a compile time error. It will not compile.
Okay.
Because it is clear that it is final, right? Final means I cannot change the value of that.
Yeah. Okay, Pawan, I got you.
Okay, so this is how in Java constants are slightly different. Now it could also be like something like this. This is a character. So I have defined a static final character. So Z is nothing but I character. Okay, this is also another way of defining constant. This is a constant, but it is a constant character. This is an integer constant. Okay, so now if you look variables and constants in Java, when I mean constant literals, I am talking about these. These are the literals that I am talking about. Okay, 10, these are literals. Hello. So if you look at these Java constant literals, these are the numeric constants and the character constant. It could be an integer or a real value, or it could be a character or a string, like any other
Okay.
language.
Okay.
Given integer constants also could also be defined in decimal. It will also be defined in octal or hexadecimal as well. Okay. So, and real constants can also be specified something like directly like 17.546, or you could also specify 2.1565 E2, which means into E, it is the exponent, okay, into 10 power 2 is what it means. I've given an explanation of what it is here. And then there are single character constants like the one that I had used, like 5x and all that. And then string constant, which is like something like hello Java 1997 is a string constant. Okay.
Okay.
And then coming to variables, now I'm talking about these kind of variables that it's like variable x is equal to 10, or which I already showed. There are certain rules when you are trying to name variables in Java. I cannot say this will throw an error because there are certain rules. Okay, when you're trying to name a variable name should not begin with a digit. It cannot begin with 9 or 1 to 0, anything from 0 to 9. It has to begin with a character. Though I can, this is not valid. It will not, but I can say hello 9. This is valid. Okay. So there are certain rules in the way in which you can define your variable names. So it's something like it cannot begin with a digit, and upper it is case sensitive. Okay. If you name a variable like with capital T and you're trying to access it with small t, it will not be able to access it. It is case sensitive. And it should not be a keyword. It should not be something that you're already using. So you cannot define it something like, since final is a keyword, it has a meaning in Java, right? So whatever has a meaning is a keyword. So I cannot define variable final because it's like, it's this thing. Okay. So variable names can be of any length. You can name the variables the way you want. Data types in Java, there are primitive and non-primitive types. The primitive ones that they have retained are the ones that were there in languages like C, C++, something like Boolean, which takes only true or false, character, which is a single character, byte, short, int, long, are four different types of integers of varying length actually. Floating point is also float and double. Float is for smaller floating point numbers and double is for if you want bigger values. The range of values that it accepts is given here. You don't have to remember all this, but you should know that there is something like this. For example, if you define that some particular variable is a byte, say byte x is equal to something, then you should know that its value can be only between minus 128 to plus 127. You cannot specify 128 or 150. You cannot give that value to a byte type integer. If you want value 150, it should at least be short. If you want again 35,000, it should at least be an int type integer. So you can refer to this and then you can assign a value. Usually you don't use byte and short just like that. You can use int or long based on your requirement. If you need to specify something more than 2 billion over here, then anything more than 2 billion you should specify it as long. And then you have some examples of integer primitive types. And then you have floating point types as well, which also, something that, you can specify something as float or double. Okay. And then you have Boolean and string literals as well, which we saw, character literals. And there are escape sequences for special characters. Something like how do you specify a backspace or a horizontal tab or a line feed or form feed, carriage return and all that? How do you specify a double quote within a string? Say for example, in if you go back to our example over here, hello earth, you see hello world is something that we have put within double quotes. Now, if I would want it to print double quotes over here, then what do I do? If I put double quotes like this, it's not going to be valid. It is throwing me an error. So for this double quote to become part of this string over here, I have to escape it. So if I put a backslash and a double quote, it means that this character, okay, this backslash double quote stands for double quote. So if I save it and I run it, I'll show. See, this double quote is now part of this string that has got printed here. So if I want to put a double quote within these two double quotes, then I have to escape it. So like that, you can specify other characters as well. Like if you want, see this is just a system.out.print. That's why it's not going to the next line. Now if I want the next line over here itself, I can put a backslash n. A backslash n is a new line character. And then now you can see that after hello world it has moved to the next line. Why? Though I have used system.out.print, I have put in a backslash n here, which is a new line character. So I can manipulate things like this as well. So if you look at the table here, it says that backspace, tab, line feed, or carriage return, double quote, single quote, all these need to be escaped. Okay. So there are some escape sequences that you could use. So based on your usage, you could utilize any of these if required when you're trying to print it. Okay, so we come to the end for today. Do you have any questions for today?
No, right now, till now, it's good.
Okay.
Yeah,
We are good.
Do you want me to go faster or slower or?
This is great.
It's good.
Okay. So where are we on this thing? If we go back to our training plan, see an introduction to Java is over, whereas variables we just looked at it. We are yet to look at operators and statements, whereas we have covered a few of these OOPS concepts over here, which was part of session 3. Now what we will do
Okay.
tomorrow is we'll look more into operators, statements and access modifiers. Okay.
Okay.
When we just look at this and we'll take our own time and we'll try to you know um, do as much practice with this, then you'll get some hands-on Java programming. Once you're comfortable with that, we can start looking into more of the class kind of concepts. Because once you're comfortable with Java programming, we can move on to this at a much faster pace. So this week we'll have 4 sessions. Next week again, the date that I have is like next coming Monday we don't have anything. Tuesday again we have, because Monday is second I think, just after New Year. Third is like around third is when I plan to finish off your core Java part. That is up to serialization. This would get over.
Oh,
Then we'll
okay.
have, and then we'll start off with the enterprise edition. It will take some more time before we actually proceed with this. The way we are taking some time before we can get into this, right? Because a lot of concepts are new. If I tell everything on the same day, you'll not get it. So,
Yeah.
so it will take some time even over here when we talk about internet programming, web concepts, REST principles, web services. There are so many things over there. So before you actually get a hang of all that, it will take some time, but then again we'll be able to proceed faster. Okay, so if there is nothing else, then yeah, there'll be some exercises. I'll forward you those exercises. I'll ask a training coordinator to forward you those exercises that you
Mm-hmm.
could use to practice. In the meanwhile, you just if you have already got that system.out.println, you could try, I'll give you some exercises around that you could try. So you get a hang of a little bit of Eclipse. Though Eclipse is a complex tool, you won't get a hang of it completely.
Okay.
If you close a window somewhere, you will find some time before you reopen it because it takes time to get a hang about on that. Okay.
Okay. Okay.
Yeah, okay. Then see you guys tomorrow. Tomorrow
Yeah. Okay.
we'll look at operators and statements and access modifiers. Okay.
Okay.
Yeah. Have a good day. I'll ask the training coordinator to mail across the exercises to you. Okay.
Okay.
Okay,
And
thank
also
you.
share
Thank
the
you.
and also he'll also be sharing the presentation as well, like whatever we covered today and the PPT and everything. You can get in touch with him for anything.
Okay.
Okay, thank you.
Yeah.
Mm-hmm. Okay.
Okay. Thanks a lot, guys.
Yeah.
Okay,
Thank you.
thank you.
Thank you so
Bye.
much.
Bye,
Yeah.
Manoj.
Bye.
Bye.
Yeah. Bye. Bye.
Bye.
Bye, Mohammed. Bye.
Bye.